And welcome everybody to our Cassandra Developer Workshop today. We have just about a minute until we get started. And with that, just like a couple weeks ago, I'm going to start you off with a really cool video here. This is my favorite one, that's why I keep showing it. And then we'll get started. So we'll see you here soon. And hello everybody, welcome to week 7 of the Cassandra Cloud-Native Workshop Series. Today I am joined by Erick ZIETLOW. Hi Erick, over there somewhere.
Hello.
And we have a special guest, Jonathan Shukinator, with us as well. Hi there, Jonathan Shuki. You know, it's
Hello.
so funny, I'm so used to calling you Shuki, I almost wanted to call you Jonathan for a second, it just threw me off, but... So all right. So Shuki is our expert today. So any of the hard questions, we're just going to throw right to Shuki and completely punt on.
Absolutely.
Yeah, exactly. All right. So hello everybody. It's good to see everyone again. So first thing I want to start with today is I'm going to pull out the slide. If you remember, we talked about our Astrakathon. Right, so we have the Astrakathon that's going on where we are encouraging you for all sorts of fun monetary gifts to create your applications, right? We talked about this a couple weeks ago, and it's getting closer and closer to the deadline to submit. I'm actually going to go ahead and drop this link in both the Discord and the YouTube chat. Hello, everybody. I see some folks saying hi in the chats.
There we go.
And that way, if you're interested in doing that, you know, if you're curious what you need to do, I just want to remind everyone is go ahead and create your own GitHub repository. Make a zip file. You know, send us a USB stick. We don't care, right? However you want to get us that code, we'll accept it. But I would say the easiest way is probably to go ahead and GitHub. Yeah, create a GitHub repo and send us that. But the information that you need is in the Astrakathon page that I just dropped in both the chats. So I did want to point that out. Okay. So as usual, and hopefully you can all see us pretty well down at the screen. Yes, we're probably pretty small today. Again, you know, we've got 3 of us here. I've tried to make it so we don't obscure the content. So hopefully we're not too small. I can always make us bigger if we need to. As usual, though, we have the regular support crew. So myself, David, Erick. Like I said, we have our special guest today, Shuki. And then we have the rest of the folks in Discord and YouTube. And as always, ask your questions if you need to. All right, so we are almost through this whole week 8 series. I'm actually kind of getting excited. Not that...
Yeah,
right?
Aren't we?
Yeah, seriously. It's been for all of you who have stayed with us, like, whoa, that's awesome. For those of you who are just joining us for today, hello there. We have all sorts of content for you. So today in week 7, this is where we're going to switch gears a little bit, right? So if you look at what we've done into this point, you know, we first started with Cassandra fundamentals, then we built some apps, and we deployed them in Kubernetes and everything. The one thing we really haven't talked about just yet is performance benchmarking your data models. And it's something that's actually quite important, but not many people actually do. So we're going to go over today a tool that you can use for this, not just with Cassandra. I'll get into that, and we're going to go through some fun scenarios. And as always, let's go ahead and get into MENTI because, you know, we're going to ask you a bunch of stuff. So if you could, we'll go to menti.com, code 812392, and I'll drop these as well, menti.com, and 812392. Well, I almost typed the wrong thing in. There you go. And here you go as well. Let me switch over to the Menti screen. Because, you know, it wouldn't be one of these if we didn't start asking you questions right away. And I'm already seeing the thumbs up. Wonderful. All right, I'll wait for folks to get in.
Everyone's joining, yeah.
Yeah.
There we go.
We'll give it a same a moment.
Awesome.
Okay. I don't know how many. I'm not seeing. How many do we have today? Okay. There. All right. I'll just give it another moment to let folks get into the Menti. Again, it is code 812392. Okay. All right, once it hits, let's go for 100. Once it hits 100, then I will go for it.
Getting close.
You know, it's funny. I said once it hits 100, I'll go for it, and then I just fat fingered a key and started it. So all right, let's go ahead and answer the first one. What's your progression in the workshop series? We always like to find out how many of you are just joining us for the first time. Are you still working on homework? Yeah, I see. This is my first time. Right, great. Hello for those who are. This is your first time. We'll let these fill up.
Look at that.
Wow, started on July 1st and up to date. Look at that.
Incredible.
Yay.
And even the ones who aren't up to date, they're working on 5 and 6. That's still incredible. Yeah. That's a lot of content.
We do realize that we did give you guys a lot of content. So.
Right. Well, we're building an entire app and all of the architecture around it. So, I mean, you know, there's something there.
Well, I will say, for those who are still working on some of the content, you'll be happy to know homework, I swear to you, homework is light this week. Homework is light this week.
Yes.
I really do mean it. It should be easy. Okay, awesome. Thank you, everybody. Let's go to the next one. What profile describes you the best? Now, in this one, some in the past have asked, hey, why isn't this multiple choice? You know, it could be multiple things. That's why we say describes you the best. We're looking for where do you think you really fit the most?
A few more administrators than we've gotten in previous weeks, I think.
Well, you know, I think our admins are going to really like today. Not that the devs and such won't, but I do think our admins are going to like today.
Absolutely. Mostly dev, but also ops. Sounds like my life.
Yeah, I think that's a lot of us these days. All right, wonderful. Thank you. All right, in 10 words or less, what can we improve? This is always fun. I like this one.
Yeah, see, these people are too nice.
You don't have to be nice.
You know, nothing.
More sysadmin topics. Okay, so for my sysadmin folks, I'm actually curious. Give us your feedback in the Discord. Yeah, need time to catch up. Yeah, give us your feedback in the Discord for the system admin folks about today in particular. Yes, Kubernetes stuff was complex. It's that one's tricky. It honestly is. Yeah, you're not alone.
And, you know, there's a little bit of that is on us too, where we had, I think, a change we put out post-workshop that not everyone was able to pick up right away. So apologies for that to anyone who ran into problems as a result.
We can just blame Eric. Can we blame Eric? Let's blame Eric. Yeah.
Sure,
I see, by the way, for
me.
this voucher, please make sure to reach out to Jack Fryer. And Jack is on both the YouTube and Discord chat, so just reach out. Matter of fact, we do have a form for that, but if you already asked for a voucher and maybe you didn't get it or for something like that, definitely reach out to Jack on that. Yes, less homework so we can stay up to date. Like I said, today you will have easy homework, so this will help.
Yeah,
extend the Astrakathon deadline, huh? I see a little winky face on that one. We'll have to see there. Okay. All right. This is wonderful. Thank you. By the way,
reliable documentation. Yeah. That's actually that is something we should probably consider incorporating more into our content. Is document links to various things.
Yes. Yeah. No, that's a very good point. Okay. So I'm going to go ahead and move on. We'll read all these later. Thank you so much for submitting. And there we go. And this one you should be able to multi-select. Which OS are you using? I'm pretty sure I gave you a multi-select on this one.
As always, Windows takes an early lead there. It's a lot more Linux than in previous weeks, though, I feel. That's it's actually getting pretty close to the amount of Windows users. Not bad.
All right, you know, that does tell us, it's so funny that so much of our instructions we've built for Linux and Mac setups, and we made that mistake. I mean, we do set up the Windows instructions as well, but we don't get as much time on those, so it's clearly something that we need to change there. The good thing is today we'll be providing both a binary and a jar that you can use, so all of these should be supported. All right, wonderful. And then this one, I want you to be really honest with this. Are you benchmarking your data models today? Totally. This is all anonymous, right? This one's really important. Be honest. This is where I get to watch Shuki's face and see what happens. This actually, I think this chart kind of makes Shuki happy, maybe, because that's the whole point of what we're going to talk about today.
Yeah, this is pretty much what we would expect to see too. You know, a majority of no's is kind of, I think, reflective of the actual industry.
And to be clear too, this isn't. There's no shame in these answers, right? For those 35 right now that have 36 that have yes, that's wonderful. That's actually really cool. And I'm very curious to hear your feedback on the types of tools and such that you're using to do that. Again, drop the stuff in YouTube and Discord so we can kind of chat with you there. For those who are, gave the answer, I mostly rely on database administrators to handle performance. Honestly, that's not surprising. For the years that I spent in the relational world, it wasn't completely uncommon that somebody else like your DBA or whatever would really be handling, say, the schema creation and the performance, what indexes to add. And then as developers, we'd be in there creating various queries. I mean, it's not that there wasn't optimization. We just didn't think about it in the same way. And hopefully by the end of today, I'll have you all convinced that you should be benchmarking your data models, but we're going to give you the tools to do that.
And to that point, you said there's no wrong answer, there's no shame in it. But after today, after you've been enabled,
today there's shame. Next week we'll have to get the shame bell out and ask the question again. No, I'm so kidding. Right. That's funny. All right, awesome. Thank you, everybody. All right, with that, so please keep your Menti open as we normally do, and we'll go ahead and get into the core of the content.
Awesome.
Woo-hoo. All right, thank you, everybody, for your input. Okay, so as we do these every week, we usually have our housekeeping and setup. Now, the nice thing about it is today this should be pretty straightforward because we don't really have much to do from a housekeeping and setup standpoint. As usual, we have both of our streams on YouTube and on Twitch. So every once in a while, if you have a problem with one, you can always, usually we focus folks on YouTube and then use Twitch as a backup if you ever need to. We're not going to be using Astra today. I am. And if you want to follow along, go for it. But we will be on GitHub. Of course, we have the live questions. The one big difference today is KataCoda. Now, you may have gotten in the workshop email from Jack. You may have seen something, hey, go sign up ahead of time. Now, one thing we're not going to do today, I'm going to ask you to not do the KataCoda scenarios live with us now. Reason being is with so many of us on at the same time, we've learned from the past that it's not the greatest experience, right? It's not really meant to be like 1,000 people just show up and start hitting it all at once. So it's much better if you would all do that for homework. We're going to go through the material, but we're just going to do it on GitHub. I'm going to cheat a little bit, and I'm actually going to use the KataCoda piece. And I'm going to show you what that's like. It's actually a really, really cool resource. Again, for those of you who have, say, lower resource machines, you don't have much RAM, maybe your bandwidth limited, something like that, the KataCoda scenarios, more than just what we're doing today, I'm going to show you a whole set of them, are wonderful. They're completely cloud instance based. You just click and go, and it handles the rest for you. So again, I just ask you, don't do these with me live in KataCoda. If you want to do the exercises live, let's do them locally, and we'll do it through the GitHub. But then once we're done and you've got your homework, you can KataCoda away. We just want to make sure we don't overload the system.
And just real quick on that point too, the KataCoda isn't just our content. There's a lot of other content out there from just a variety of different technologies and providers and things that it's a great place to go just to pick something up and kind of learn how to use it kind of zero to hero very, very quickly. So.
Okay. All right. So with that, so again, we're going to skip this part of it of doing the sign up. If you haven't already signed up for KataCoda, just do that after, and that way you'll have a much better experience. Okay. So what I want to do at this point is get into the NoSQL bench what and why. So part of the whole point of today is to introduce you to NoSQL bench. This is a free open source tool. It's available on GitHub. I'll be giving you the links. It is a serious performance testing tool for the NoSQL ecosystem. That's essentially what it is in a nutshell, right? Now, one thing I want to point out is that even though what we're going to be doing today is working with Cassandra, I actually have a whole set of different clusters set up. I have a Cassandra one, I have Astra, and I have DSE. But NoSQL Bench isn't just made to work with Cassandra. So if you notice the name, it's NoSQL Bench, not Cassandra Bench, right? So it is a pluggable. It's based on a pluggable architecture that allows you to plug in all sorts of different NoSQL technologies, whether that's Kafka, you could hook it up to Mongo, you could hook it up to multiple different types of Cassandra databases, you could hook it up over regular HTTP or, whatever. It's got all these little plugs and a whole set of different drivers and everything that allow you to hook it up to other tools. Now, Shuki, I don't know if there's anything you want to say more on that, if there's been any new developments on that front, any new drivers or anything that you want to tell folks about?
No, I think that's a good summary. We are constantly trying to flesh out the drivers that we have and make them more complete. Most of them that we have in the list are fairly usable in the current state. You can use them for benchmarking. They're pretty performant. They're pretty flexible. There are a few that are in prototype, basically demonstration state, like the WebDriver one is something it's out there. But in order for it to load the complete syntax aside files, we need a contributor to come on and to help us to add the stubs in for the other verbs that are available from the Selenium IDE recorder format. So if you're looking for a type of driver that's not there, or if you want to know what the state of the drivers that are there, just come to the site, check it out, or join our Slack and ask questions, because we're almost we're answering questions all the time there. So just come and ask if you have any questions, and also check the docs. The docs are pretty
and I will.
So do you accept pull requests then if someone wanted to contribute and add to what you have?
Absolutely. Yes. No. Because so this is a sophisticated tool, right? I mean, there's a lot of work that went into making it flexible enough to work for different kinds of drivers without making a bad trade-off. So there's a little bit of acclimate for is that the right word? For new developers to see how it works internally, but if they're willing to put in the effort and learn, it's a cool tech to be able to work with, and you'll have a good support system, and the project maintainers that are there will help people learn how to submit pull requests that are appropriate. If needed, we'll give good feedback, but we're more embracing than anything else, because we actually do want to make this a community-owned project, at the most fundamental level. And we're just the first contributors, and we're trying to broaden that group as much as we can. So we will definitely help people get started.
Awesome.
Okay, so again, we haven't even stepped into yet, like using NoSQL Bench and what it can do for you and everything. But the base thing to understand is a performance benchmarking tool, for your data models, right? And as we saw in the numbers in the beginning, a lot of you are not, in fact, performance benchmarking your data models, which is really important. So why? Why do we want to benchmark? What's that about? So if you think about it, you spend all this time creating these wonderful denormalized data models and such in Cassandra. If we're focusing on Cassandra here, you've got your application that is built on those data models. And what you don't want to have is, as your data grows, as your throughput increases, as your users increase, that you have a Cassandra cluster that essentially turns into a big fire with all your nodes going down all over the place and running out of control, and just, I love this image, by the way, this GIF. Alex tells me that's actually from Russia. But this is what we're trying to avoid, right? We don't want this case. And what's really clear here is something that, as we've been doing these types of workshops and a while ago when we were doing a lot more in-person events, I can't tell you how many times we ran into folks who said something like this. Man, this Cassandra thing is supposed to be so fast and everything, but we were like a year into our project and our Cassandra, our Cassandra nodes in our cluster just went totally belly up and it's really slow now. Like, how is this fast? And then we do a little investigation, look in their queries and such, and we say, oh, well, you're using allow filtering on every single query. And we've talked about allow filtering in the past and why that's bad, right? Or there are various things that are in the data model that aren't really doing what they should be doing. And if you're not performance benchmarking your data models, then you're opening yourself up for this potential, right? So that's what we're after. We're really after trying to ensure that we at least have an idea of what kind of performance we should expect with our data models, with the data density that we'll eventually have, so we prevent this particular scenario.
Yeah, and sizing too. I mean, if you're not testing, you have no idea of how you're sizing, how to actually handle your sizing of your clusters. That's a huge thing. You could be right on the cusp of what you can actually handle, and you need to scale to be future-proof. But you wouldn't know that unless you actually do some testing.
Yes, yes, exactly. All right, so with that, there are tools that have existed. It's not like NoSQL Bench is the first tool to come up and do this. A lot of them, though, they kind of require, they're kind of terse. They kind of require a lot of esoteric knowledge to even get going. NoSQL Bench, even though it can be extremely deep and capable if you want to go there, and Shuki is here to totally geek out if there's any of you who want to geek out on some of the more technical aspects of doing benchmarking. But NoSQL Bench was designed to get up and going very quickly, right? Within a command, boom, you're actually running performance tests. So that's what we're going to go through today. And so with that, here's just kind of a shot. You're going to see a lot of demoing today of NoSQL Bench. So as part of the repo, if you go to that repo that I dropped, you'll find down here, you'll have docs. Now the docs, you can either go to the docs online, or when you download NoSQL Bench locally, you will be able to launch a doc server right out of NoSQL Bench as well. So however you go, there's docs in both cases. Let's see. Another piece of NoSQL Bench that you get that is really neat that I'm going to show you a lot today. Now, in the past, with some of the Kubernetes stuff, we worked with Prometheus and Grafana to do some of our benchmarking, some of the visualization of our benchmarking. That's embedded, right? Now, NoSQL Bench comes with that embedded. So you can just kick that off, and it will actually launch the Docker containers and get all that going. I'm going to show you that as well. And it's a command line parameter, right? It's really, really simple to use. So, all right. So with that, let's get into our first section here of executing commands. Before I do that, though, I'm going to check the chats. Let's see what we have going into the chats. We have anything we need to...
We're pretty current. It looks like Ramirez and Bettina are really on point here.
Okay, I do see a question from Frank Damane, who's asking, do you have a white paper on dimension and performance design?
Ooh, good question.
What do you think, Shuki?
I don't think we have a white paper on that, but I'd like to investigate that a little bit more, and maybe we can try to do that.
Okay, so with that, then Frank and I, we actually have a relationship out on LinkedIn and such. So Frank, if you're listening there, go ahead and reach out, right? And let's see if we maybe can get you guys connected up and get you what you need there. Okay, what's the Slack group for the... Okay, good. Okay.
One question here, is Couchbase supported? Is there a current driver for it?
There's not a current driver for it, but I think I've heard people ask if they could contribute or work on one. And absolutely, if somebody has the interest and the time, help us build that and prove it out for other people to use, we'll add it to the project. It's not a big deal.
Awesome.
Okay, wonderful. All right, so with that, what I'm going to do is we're going to go into the first section here, executing commands. Now, again, what I'm going to ask you for now is if you do want to follow along and do some of the exercises, that you actually do them in the Docker scenario on your laptop. Now, the good thing about that today is you only need like 4 gigs of RAM. You don't need nearly as many resources as we did for the Kubernetes stuff, so that should be easy. NoSQL Bench itself is actually really, really low weight, so it's not going to cause a bunch of resource utilization, so you should be good here. I, again, ask you to not do the KataCoda scenarios now. We're going to save those for homework. Okay, so with that, let me go ahead and drop the link into the first part. Just a couple things to point out as well as we do this. And again, this is the regular repo. Let me go ahead and this is for week 7. I'm going to drop these in. There we go. Okay, so something I want to point out, when you come here to the home page of week 7, you're going to notice the NoSQL Bench KataCoda scenarios, right? So this is one of the links. If you click on that, then you will go to the KataCoda piece where you'll be presented with the 3 scenarios that we have. The scenarios that are in KataCoda are nearly identical to what we're going to do in GitHub. So again, we're offering you both solutions for whatever fits your particular needs. I also want to point out, though, down here at the very bottom, the DataStax KataCoda scenarios. So if you take a look, all that is katacoda.com/DataStax. Now, we've been hard at work in the behind the scenes, not our team directly, but some of the other teams at DataStax, to bring you even more stuff in KataCoda. And by the way, this is all free, right? Following our normal pattern, it's all free. There's no paywall. And things for those of you who've been going through the Academy courses like DS210, DS220, you're going to see certain things like data modeling in Apache Cassandra, Apache Cassandra Learning for developers. If you click on one of those, you'll see this is pretty much a repeat or a replication of DS210. And, we're moving stuff into this. And what's really cool about KataCoda is, unlike the VMs that some of you have to download, which are huge, especially if you're on limited bandwidth and such, you can just start these scenarios and they will spin up a Cassandra database for you in those cloud instances online, right? So again, for those of you who have lower resources and bandwidth limitations, these KataCoda scenarios are wonderful. I just want to point out that there's a whole set of different courses that are in here. They're worth checking out. Eric, were you going to say something?
I was just going to say, it is really cool because they're self-contained.
Yes.
Everything you need to actually learn what's in front of you. There's no extra setup on your end. You basically just go here, click start, and you're good to go.
Right.
So really, really cool stuff.
Right, exactly. Yeah, so again, take a look at them and let us know what you think. Always give us your feedback. Okay, so with that, I'm going to go into the first part of the README. Drop this, and I'm just following the table of contents right there in the GitHub. And everyone, please let me know if you can read this. If I need to blow up the page a little bit, I can always zoom it. So just let me know if it's okay. Now, I'm not going to sit here and read all the stuff to you. What I am going to do is I'm going to go through some of the instructions. I'm going to kind of demo some of the stuff as we're going, like we were playing through those KataCoda scenarios. Okay. All right, so for the first thing, at this point, I think in this series, if you've been following us along, you most likely have Docker installed. Even the NoSQL bench itself does not require Docker to run. The metrics piece with Prometheus and Grafana does, right? So we need to go a little bit bigger. Here we go. Let's see. Hopefully that'll be better. You let me know.
Can we expand the text?
I just did.
Yeah. A little bit beyond. Okay, yeah. There we go. Sorry, I was reading the question as you were saying it, so I kind of did the...
Yeah, just let me know if that's better, and then I'll keep going on. So, and for those of you just joining us today, if you haven't been with us or if you don't have Docker installed, I do highly suggest using the Docker metrics command line parameter. I'm going to show you what that's about. So if you don't, maybe do this a little bit later, but it is just giving you the instructions to start up Docker. Now, the first thing I'm going to do is start Cassandra. Now, I think I've already cheated. Yeah, I've already got one running, funny enough. But if you literally copy this command, this will be enough to get you a base Cassandra, a single node installation going in Docker. This should run on a 4 gig system, no problem, right? So it only takes a moment, and then you'll see if I did something like a Docker PS and make it so you can see, yeah, I've got Cassandra running right here. Right, so we do need a database that we're going to work with, right? Since we're going to work with Cassandra today, this alone will go ahead and get you Cassandra. And then the next thing really to do is to download NoSQL Bench. It's like 130 megs, right? It's not that big. So if you're on Windows, just click the link here. If you're on a Mac, you could also do a wget. But to be clear, if you do that, I want to make the distinction between Windows and Mac need to use the jar. Linux uses the binary, right? So if you do the wget, notice that this one is the binary, but we did provide the link right here. It will give you the very latest. That is what I'm using as well. I'm using the jar today because I'm on a Mac. And that's it for the initial setup. NoSQL Bench. Once you have Docker running, if you're going to use metrics, and you've downloaded the binary or the jar, that's pretty much it. Everything else that we're going to do is going to come from running against the NoSQL Bench piece. How's the font looking, everyone? Is it okay? I did increase it. Let me know if it's okay.
It's looking pretty good on my end, so.
Okay.
I'll let you know if anyone complains.
All right, so what I'm going to do is I'm going to move to the next section now. And this is going to be where we're going to start executing commands. Now, I made a claim in the beginning that NoSQL Bench, it's been designed to be able to get you up and going very quickly, very easily. So this is what I'm after here. So again, I'm just following these steps that I have in the GitHub repo. So notice here, we do provide both of the commands. So if I'm using the jar, then I need to specify java-jar, the name of the jar, and then I'll explain what this is in a moment. Or if I'm using the binary, NoSQL Bench, then I can just pass this parameter to the binary, and that's it. So what I've got going here is, hopefully these are big enough for you. Again, let me know if it's not. I've downloaded the jar, and I'm going to go ahead and issue this first command. Now, I'm purposely glossing over a lot right now. Now, remember, I started a Cassandra database that I have running in Docker, right? That's what's going on right here. And you'll see logs going by of it doing things that the scenario here, the workload is asking it to do. But the very, very simplest, what I just did here is I essentially initiated a CQL IoT, an IoT workload against NoSQL Bench. And it is now going to my Cassandra database, and it's issuing commands, it's creating schema, it's ramping up data and everything. Now, I purposely glossed over a lot. We're going to get into the detail of this. The point of me showing this one thing is the fact that all I had to do in the case where I had a local database running at the default of 9042 for Cassandra was just run a workload, and NoSQL Bench will get to work, right? To also kind of just further that out, if I go to CQLSH, there we go, and if I take a look at my key spaces, okay, the one for NoSQL Bench by default is called baselines. That's the one it's going to create. So if I use baselines, and if I take a look at the tables, I will have an IoT table. And if I select some data, if I could only type it. There we go. And I'm just going to, there we go. So there's some data. Now, again, we're going to go over how this data got in here and what's happening. Again, I just want to point out, start up a database, I run the thing with a workload, and boom, it's starting a performance test. Now, if you're doing this with me, it's a good idea right now at this point to go ahead and Control-C, because this test, if you notice, is going to run. It's going to try to create 10 million rows, which I'm not going to do right now. We do mention that in the instructions, right? But again, I just wanted to kind of point out, that it's quick and easy to get going. Notice as well that it tells me where it's logging. So if I take a look at my directory here, right, you can see I have my logs directory. So it did tell me, oh, okay, I logged the output to this particular log file. So, if I wanted to, I could just cap that or completely do that wrong. I guess that didn't copy the way I thought it did. Let me do that again. There we go. Right. So logs and everything. Again, we're going to go through these later. I'm not going to bore you with that at the moment. Oh, still bigger font? Still bigger font. All right, bigger font. Oh, in the terminal. Okay, yeah. I blew that up earlier. I guess it's not big enough. All right. I get it. Hopefully that's better. All right. And then finally here, from just a quick cleanup from the command we just ran. When we ran that CQL IoT workload, it actually created a schema, ramped up some data, and started a test. Again, I'm glossing over a lot. I'm just going to clean things out. I saw somebody asking about this in the chat. So one of the really cool things you can do with Docker is you can issue commands to the underlying containers that are in Docker. In this case, we have a My Cassandra database that we started with the command here, right, called My Cassandra. So I've got a Cassandra cluster running in the My Cassandra container. And so what Docker allows me to do is I can execute a command against that container. In this case, the command is CQLSH. So all I'm doing is I'm saying drop key space baselines. And then once that finishes, there we go. If I look at my database, I can see I no longer have a baselines key space. I bet I have to blow that one up too. Okay. And again, the whole point of that was just get you with an initial workload just to run, just to kind of get the feel for how that goes. There it goes. Okay, here we go. All right, so the next step, here's what we want to do. We want to go ahead and create a test schema. So again, I have the key commands, or the commands in both the jar and the binary. So let's take a look here. So notice now I'm going to create a workload called key value. And it's tag space schema. Now, again, I haven't broken this down yet. I just want to show you, I'm going to illustrate some things, then we're going to get into the details. So what this just did, because I actually called a schema phase, is it actually created, it used the DDL commands to create my schema, just like create key space, create table, right? And it created the needed key space and the schema for our particular workload, the CQL value. So if I take a look at my key spaces, right, I've got my baselines back. Oops, got a semicolon. Now if I describe tables, I have a key value table, right? So this particular workload, now to make it so it's not like completely amorphous of what's going on here, and a couple more commands, I'm actually going to start showing you the files that are underneath and how this is being built. Just know at this point, all I really said was go ahead, create a key space, create a table, and that's it. There's a couple things in the command that you want to point out. Notice this driver CQL. So CQL is actually saying I'm going to issue a CQL command. By the way, this is all in the NoSQL Bench docs. No one's expecting you to memorize all this kind of stuff. I'm also specifying the workload. In this case, I wanted to run a CQL key value workload. Now you might be wondering, you just saw me run a CQL IoT, CQL key value. Some of this might seem a little abstract at the moment because we haven't gotten into the files. Can you create your own? Absolutely. We're going to do that by the end of what we're doing today. Okay, and then the next part, again, I'm going to use my friendly Docker to do essentially what I did in CQLSH, where I'm describing the new key space that we created. You notice that I have this key space here, baselines, and then the table with that particular workload. All right, let me check the chats. All right, cool. Yep, go ahead, Eric.
Oh, no, I was just saying we're pretty good in chats. I did see one question, though. Someone's asking here, they want to do these exercises on Linux. Will we provide a server? That is actually what KataCoda is for. So you can actually go out to KataCoda, and none of that runs locally on your box. That's all up in the cloud. So please do take advantage of that.
Yeah, and if you are looking for, I don't know how much resources you have on the particular Linux box, but like I said, because we're only running a small single node Cassandra cluster as at least a base test, you should be able to run that in a 4 gig machine just fine, right? For our purposes of what we're doing here, yes. I would say, if not, then as Eric said, KataCoda is the way to go. The cool thing about KataCoda is it will provide the exact commands just as we're doing here. And also you can experiment, you can modify them, you can play around while you're in KataCoda. And as you work things out there, then you can take those commands to your own system and use them locally. Okay, so the next one here is a little bit different. Here's what I want to point out. Notice this driver standard out, right? So what we're going to do here, where CQL actually executed the CQL against our database and created a real schema. In the case of standard out, this is really good for cases where you just want to see what is the output, what are the values that are going to be determined or created in a run. So not only did we say driver standard out to print this as standard out, we're saying, okay, I want to issue against the CQL key value workload. But this time I'm going to go into the ramp-up phase. Now, we're going to discuss more about what that means, but essentially in NoSQL Bench, you have 3 main phases that you need to care about. Schema, ramp-up, and main. Schema is creating the schema, right? Get my key spaces and tables in place. Ramp-up is populating the system with my data and getting me at a level of data density that's going to match what maybe my application or my experience is projected to have. And then main is the actual performance benchmark, right? So what we're saying right here is, in this case, I want to go ahead to standard out with the CQL key value workload, issue 10 operations, the cycles and operations. So I'm essentially going to create 10 queries, 10 operations in my ramp-up phase. But because I use standard out, I'm just printing that out to the screen. This is a really nice way to actually look at what my values might look like before I start inserting data into my database. So there's nothing in here at this point. If I were to go ahead and take a look at the data here, I shouldn't have anything. It's empty, right? So even though I generated what looked like insert statements and such, I printed it to standard out, not through the CQL driver. Okay. Let's see. And I'm just looking at some questions. And Shuki, I don't know if you have anything else or anything that you want to add to the things I'm saying as I'm looking at questions here.
I think I like the presentation. I think you're covering a lot of good details here. But if there are any questions that are outstanding, there's one I saw back there I'll respond to briefly.
Okay.
Somebody said, is NoSQL Bench better than Stress? Well, they're different. You can think of Stress as a tool that knows how to drive some traffic to a cluster. It stresses the clusters. It's a very different scope of a tool. NoSQL Bench is really a combination of a design framework for agnostic driver runtimes, where you can use a driver like a cartridge, plug it into the runtime, do some scripting, and have all that work in a consistent way from one system to another. But it's also a workload simulation tool. So we put a lot of energy into making NoSQL Bench behave on its client side much like applications do. So the kinds of things that you can emulate with it and with little effort are way beyond what you can do in the user mode in Stress, for example. And furthermore, you can look at the results, like as David is showing here, you can look at the results in the database and look at the recipes that made those operations and know that it's completely traceable, reproducible, deterministic to what degree you want. And you can verify that it's doing exactly what you want. So you know what your test is doing, and you can shape that and size that to whatever scale is needed to be realistic for your scenario. So that's very different than Stress in those ways. And the origin story here, I'll be quick.
I feel like I need some superhero music right now.
Yeah. It started because we needed to do some specific kinds of testing with Stress, and we couldn't make Stress do it. And the architecture of Stress was not amenable to the kinds of changes that would have to happen to make it do the kinds of tests we wanted to do at the time. And so we needed to start with a new architecture, and that's what NoSQL Bench started out as.
Yeah, so I got a few things here. Chat is absolutely blowing up asking for a Docker course, so we might look into something around that in the future here. Really good feedback, guys. Thank you for that. Also, question, how did NoSQL Bench know where Cassandra was in the commands you ran previously, David?
Okay, so that's a great question. So like I said, in the beginning here, we've glossed over a lot. So NoSQL Bench, by default, if you do nothing else, is going to default to using localhost 9042, where Cassandra would be if I'm using the CQL driver, right? So it is assuming that that's where I'm pointing. Now, I saw another question. There's a follow-up. I saw another question about how come we're not using Astra? I will be later, right? And I'm going to show you how to do that. The cool thing about it is as we build up the parameters that you can pass to NoSQL Bench, you can very easily point it to another host, which I'm going to show you, or Astra or whatever. So it's just defaulting to localhost 9042. That's all.
I saw a question from Jose Mata. Is it possible to mix real and generated data? I think we'll get into some of this, so we'll table this answer till later because I think David will answer some of your questions as we go.
Yeah. I think, though, the general answer is yes.
Yes.
The answer is yes. All right. Okay, so with that, so you saw I just did standard out at this point. So what we're going to do here as we move down is we're going to essentially do the same exact thing. We'll take a look at the comparison of the commands. That's the command I just ran. Here's what I want you to notice, right? The difference is the driver. Notice in the standard out, all it did was print to standard out, but in the case of CQL, it is now going to connect up to that, again, since I'm not configuring it to do anything else, that localhost 9042. When I run this, it's actually now going to insert those real values into my table. Okay, so it's done. So remember before, when I selected from the table, oops, how'd that get? That's weird. That's a new one. Oh, wait. I think I see what's going on. There we go.
It's typing on
There we
screen.
go. There we go.
Yeah,
okay.
Typing on screen never works the same.
Okay, so notice now when I select from the key value table, I have that data, right? So I just want you to understand the distinction between standard out and the CQL driver. By the way, there are a whole set of other drivers, but for today, those are the ones we're really going to be focused on. All right. Then the last piece here, I essentially just did this, but again, if you want to do it from Docker instead of Apparently I did not. Try that again. There we go. So if you want to do it from Docker, you can. You'll find that this does the same exact thing. Again, I'm just executing a CQLSH command against my Cassandra container where I have that running, and I'm passing it this query. It's the same one I ran up here, so we can see that I actually have results in my database. Okay, so then the final... Oh, go ahead.
So,
yep.
Quick question here. Astra, if someone's running Astra and they wanted to use NoSQL Bench, how would they go about doing that? Is it just CQLSH driver? Is there something more they need to do for that?
It is almost identical to what I'm doing here. The only difference is you're going to actually add in a Secure Connect Bundle parameter, an option in the command line. I actually have an example. I'm going to show you that here in a moment. That's it, though. That's awesome. It. Matter of fact, just like if you remember so many weeks back when we talked about using the drivers, right, that hook up to your Cassandra database. If I had a 1,000-node cluster, I don't need to provide all 1,000 IPs, right? I only need to provide a handful.
Right. You just need to gain awareness.
Exactly, and then the driver will then discover and gossip with my nodes. It's the same thing here. NoSQL Bench is using the driver, right? All I have to do is provide it that initial entry point, and it'll do the rest of the work for you via the driver.
Absolutely. So one more question here, and then I'll let you get back to it. Ramp-up phase is what exactly? Yeah. Obviously, schema sets up your schema. The main phase is actually let's put some data where we want it. What is the ramp-up phase?
And I have a feeling that Shuki's going to want to say more on this one, but I'll go ahead and give a start and then let Shuki finish, right? So the ramp-up phase, if you think about it, when you are looking at the running experience of your application, right? You have your initial data load. Maybe your application's brand new. Maybe you don't have data yet. But at some point, you're going to get to some, say, nominal amount of data that's going to be in your system that's coming in at some regular pace. Or maybe, a whole data set that you have in a table that's very read-heavy or something like that. But you're going to have, some set that is going to kind of be the representation of what your application looks like in reality. That is different. That is wholly different from having 0 rows. Right? And so if you think about it, not only that, think about things like your key cache, right? Before your database is warmed up and you're starting to experience the kind of reads and writes that you might get, that's not when you're ramping the data up and you're just adding the data into the system and you're executing those queries, then that's not a really realistic experience of what your application is going to look like once you're at data density. So the ramp up is there to get that initial data load in for you, and it's preparing you for the main phase where you're actually running the benchmark. Shuki, do you have anything you want to add to that?
Absolutely. So you want the short form or the long form?
I say short form for now. and if we need follow-up, we can do it.
Sure. So the ramp up is different, not just because it's a separate step. It's good to call it out as a separate step. But we actually design it differently in the workloads when you were building the baseline, like the default workloads that are they're bundled. We build it differently. And the distinction between how ramp up works and how the main phase works is that with ramp up, as you'll see in some of the examples David will show, there are parameters that determine how many operations you do, but really it also determines specifically which operations and how the data goes into those operations. So we have the how to add data into the backdrop of our system to make the results realistic, because read patterns always follow the binary search order of growth, basically. So you want to make sure you have adequate data in there to test with. So what ramp up does is it lets you incrementally add rows into the database in a way that you could say, I want to add 1,000,000 rows, I want to add 1,000,000 more, and because of the way we set up the data generators for the ramp-up phase specifically, that's an incremental process. There's a one-to-one mapping between the data range that we use to control the test and the rows that are projected into the data set. And we can incrementally add on to that without skipping anything and without overlapping anything, and make it as big as we want to and stop when we think it's there and say, okay, we know how big that needs to be in the system, compression, data model, all that stuff. Main phase is different because main phase may have random type of access patterns. And so that's different than laying in data like you're building a log cabin from a known point going up further and further. The random access patterns are completely different. So because of that, the data generation needs to be tweaked a little bit so that you have effective fast build-up in the ramp-up phase, an incremental build-up that you can gauge the size of it, and then the main phase, which is actually the real simulation.
Cool.
That's the short version.
Yeah, that's the short version. Yeah. So hopefully, I saw the folks online. I think J12 in Discord was asking about that, and I saw a couple others. Hopefully, that got you a little bit more detailed explanation than what I gave. Again, if you need more, by all means, ask. Yeah, Eric, it sounded like you had something.
Yeah, just one more thing. I'm sorry.
Yeah.
I
No
know
worries.
I said one more last time, but so asynchronous versus synchronous. How do we actually start getting into that? Am I kind of getting ahead of you here? Or?
Yeah, so I gloss over it because, again, what we're doing, the reason why we've built these exercises in this way is because we didn't want to start all the way down the rabbit hole, right? So we're starting off very, very high level, and then we're going to break it down and break it down. One of the things I've glossed over to that point, Eric, is the start compared to run. So if I want to run things in a synchronous way, right, I would use run, where I'm going to go command, 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 command. But start, in fact, was the asynchronous version of that. By the way, this is all really spelled out in the NoSQL Bench instructions and the documentation. So there are going to be some things that I might gloss over here a little bit. But yes, you do have the ability to do both modes.
Awesome. Wonderful.
Oh, yeah. So J12 asking about cycles. Guess what? I was just about to go there. So J12 in Discord kind of played straight person with me. Yep, no problem. So if we take a look at the command here on the screen, again, we have my driver CQL. We're using that CQL key value workload in the main phase this time, not ramp up, not schema, but in the main phase. But notice what we're doing here. I'm saying cycles equals 100,000. What does that mean? That means I want to issue 100,000 operations. So depending on what my main phase looks like, in this case, I have I have either read or write queries. I'm essentially going to issue 100,000 queries. The cycle rate is how many of those per second, right? So I'm limiting it. I'm limiting it to 5,000 operations per second is what I'm saying, spread out over 50 threads. Now, I know, again, Shuki probably has something to say about this. You might be asking about the cycle rate, why. If you think about it, if you have a particular throughput that you're expecting or that you want to test for, the cycle rate is a really nice way that you can then game what that throughput is essentially going to be or how many operations per second you were going to send in the system. Shuki, you have anything else you want to add there?
Yes. Just a bullet point. Put it in your back pocket. Think about it. It'll be a topic, I'm sure, later. When we're doing testing, we don't want to test the operational data stores at saturation load. You would never run a production system at 100% utilization. So you need to have a way of throttling the workload so that it fits right in line with what you think of as a safe high watermark on your system saturation. And you can do a saturating test without using the cycle rate to find what those boundaries are, like pummel it, figure out what it can do at saturation. Maybe when you do that, you force some timeouts and things like that, so you can make the timeouts not interrupt the test by using errors equals warn. But you figure out what the saturation load is, and then given that, you say, what's a proportional nominal load for this in production? And you want to test with that, because that's going to give you the realistic view of response times. If you're looking at your latencies with a saturating load, that's not realistic at all. It's going to mislead you about scale planning. So you want to make sure you build in that headroom into your test, and the cycle rate lets you do that. And that's the main practical use for it.
Very cool. Okay, so and then the last thing here is this progress console. That's essentially going to spit out some progress. When we ran the first CQL IoT, and that was it, with no parameters, notice it just kind of gave us some, log reference every once in a while, but it didn't look like it was doing much. This progress console is a nice way we can kind of see what it's doing as we're going. So every 2 seconds, we're going to see an update. So in this case, now that we've ramped up our data with some initial data, we're actually running our real performance benchmark, right? And if I just let it go, it's going to run for 100,000 cycles. So you're going to see, as a matter of fact, because I have so many, the various threads and stuff, it's actually burning through them. So it's right now running through those 100,000 operations on my single node Cassandra cluster here in Docker. And once it gets to 100%, that'll finish out, right? All right. You're right. You'll see this output. Okay, and we'll let that finish. Good. Then the last thing I want to go ahead and look at for this particular section is remember the logs from before. So let's say I'm going to go into my favorite editor. I'm going to take a look at a log. And actually, you know what I really want to do? I'll use the cat. Yeah, I'll do it this way. I'll just use the command that's in here.
I was going to say, you're going to start a war there, man. You're going to get some Emacs people
good.
In here getting all
well, you know, for those folks on Windows, they're like, dude, what's this about? Yeah, anyway. So what I'm going to...
I use edit.
Yeah. So I'm just going to go ahead and grab this log file. Notice what we're doing in the cat here. We're grepping the type timer. There's a ton of information that's in the logs, not just the metric information, but what I really want to highlight here is the metric information. So what you'll notice, now by the way, you're going to see that for all of these, there's all sorts of metrics that are being collected. We actually kind of illustrate what all of these are here in the GitHub repo, and we do it in KataCoda. I'm not going to go into what all of these are. But for those of you who are familiar with doing any kind of analysis or benchmarking, you should recognize some of these. A lot of times in the Cassandra world, you're definitely going to be interested in your P99s, your P999s, things like that. So all of these are explained. They're also explained in the documentation. So like I said, we're not going to go into that there, but they are all in the logs, right? You can get them through the logs. But if you can imagine, there might be nicer ways to look at all the data that you potentially have coming in for all the different metrics, especially if you have a multi-node system, right? Going through the logs for all of that would probably be pretty daunting. So yes, it's there, but can you export that data? Can you get that data to something else? Yes, the answer is yes. So what we're going to do, though, is I'm going to stop here. We're going to go into our first quiz, our first Menti quiz. So let's go back over to Menti.
Awesome.
Yeah, Menti time!
Get your phones out. Get ready for some questions.
Oh, good. I already see the thumbs up coming in. Great.
Yeah, they're coming in quick. See, it's because we're offering, prizes for this part that they're so quick on the thumbs up.
Yes, and again, the code is 812392, menti.com. 812392. I think most of you, I see a lot of thumbs up coming in, so I'm assuming that folks are there. Okay. All right, good. We're at a...
Yeah, it looks like we have, 116. We have 400 of you in YouTube chat here. Come on, guys.
All right, so again, do not forget, there might be lag in your video feed. Please watch your phones or wherever you're running Menti to ensure that you can get the quickest response possible. I have so many things running on my box right now; it's kind of lagging. All right, well, we'll let players get in. Let's see what kind of fun we're going to have today. Again, look at your phones, watch that. There might be lag in the stream. NoSQL Bench only works with Apache Cassandra. True or false?
Man, that's a long time we're giving them for a true.
Well, false. we gotta kind of give time for folks that might have some lag. Right. So
yeah, true.
So yes, the correct answer is false. Again, the name NoSQL Bench, it is a tool for the NoSQL ecosystem. Like the drivers that we already have today, Kafka, Mongo, HTTP, all sorts of other things that are not limited only to Cassandra. So you can in fact use it for more than just Cassandra. It is not only for Cassandra. All right, next one. Oh, I'm sorry, leaderboard. Duh, I forgot about this part. All right, let's see. This is the part we always get excited about, and I just totally skip. Whoa! This one was probably one of the easiest questions to read because we usually have like a wall of text, and the times were like identical here. This is great. All right, so we got Shammy on top. Vinicius. I'm going to go and RSH. That's great. All right, let's see what happens in the next one. How do you select the schema phase of a workload? Schema.
Oh, that's a little small to read. Yeah, Are you able to expand that window?
I don't think it lets me. I could try. No, okay. It's not really letting me. But don't forget, it's on their phones. Yeah, look at your phones.
Yeah, true.
I think my favorite one is set phasers as schema. See what happens. We had 5 people who went for set phasers as schema. I do appreciate that you answered that. But yes, it is tags equals phase : schema. Now, somebody asked earlier about the tags thing.
Wow.
And right now, that might seem, again, a little abstract, like where did tags come from? As we get further down, this is going to make more sense. You're going to start to see where tags come into play into the YAMLs. My goal is that's going to start connecting some dots for you. So yes, it was tags equals phase colon schema. And let's see what the leaderboard looks like.
This will switch it
Brand
up a
the
bit,
Broken, nice. I always love these names. All right, cool. So we're starting to see a little bit of a spread. So Mo, Sasha, and TDH on the top 3. All right, next.
All within 50 points of each other. So
I see swag. That's funny. What driver do you use to review an activity without inserting data?
Ooh.
Driver equals review. Driver equals standard out. Driver equals view only. Or driver equals would. And yes, it's standard out. Exactly. So if you only want to review an activity, you don't want to insert the data, start with standard out. Once you're ready, then you can change it to a driver like CQL. And for those who answer driver would, awesome. If you don't want to win the swag, that's one way to do it. All right, let's see what happened on the leaderboard. I've learned to wait for this part to come in. Otherwise, I'm always getting excited. All right, so Mo, Sasha, and TDH are holding the top 3.
That's
great.
Yeah.
Here. Brand the Broken. You can do it. You can do it, Brand the Broken. All right, cycle rate. 5,000 means limit the test to 5,000 operations per second. Limit the test to a max of 5,000 operations. Limit the test to 5,000 cycle per minute. Or slow it down, you're pedaling too fast. Yes, limit the test to 5,000 operations per second. And of course, you could change the cycle rate to be whatever you need it for your particular system. Let's see the leaderboard. Dun, dun, dun. So I think Bettina and Eric are playing it today too. Oh, TDH takes the top. Sasha steps up a level, and we've Krishna gets into the top 3. Wonderful. All right.
Bit of an upset there, yeah.
All right, to find performance metrics in the logs, go to the logs performance directory, set performance equal to true, search for type equals timer, or eat more protein. And yes, search for type equals timer. I will say, though, looking at the amount of answers that were incorrect, then we could probably do a little bit better job on our end of explaining that one. But I did it. That was kind of tricky. Logs performance directory. There's logs directory, but there's no logs performance directory. But it is that search for type equals timer. The performance information will be stored in the logs regardless. You don't have to set a flag for that, so you are looking in the logs there. Again, we're going to show you a way here in a moment to how to get the performance metrics in a visually graphical way that I believe is...
We kind of worded that one a little tricky.
Yeah, we did.
Well.
We were kind of...
have to really be close to see.
It's just a little insight there. We're not a fan of having the metrics in the logs. It's rather difficult to use. It's just the minimum needed if you don't use any other options to have it somewhere. The default somewhere is logs, but there are much better ways. We'll see.
Yeah, exactly. And honestly, the way that your team set up the Docker metrics piece with Prometheus and Grafana is so darn easy that that's just the way. Anyway, so top 1, TDH is keeping the top there. Massey, Archaon, or Rakan. I see. Oh, Rakan. Oh, is that what that is? Is that like? Are we doing another Game of Thrones thing there? Or maybe I'm reading too much into that. I see Lord of the Rings. All right, wonderful. All right, so that's the stop of the quiz for now. We're going to go ahead and move into some more of the material. All right. Yeah, okay, we're just going to pop right over here. All right, so with this, at this point, we should have gotten to the point where we essentially looked at the output of the logs. The next part here, now we're going to get in to the metrics piece. This part, honestly, starts getting into some really, really cool stuff. So check this out. So notice this command here. Again, this should look pretty familiar. We're just going to issue the CQL IoT workload with a cycle rate of 100. We're going to still spit our progress out to the console, but now notice this -- Docker metrics. This is so powerful, this one little thing, because that one parameter, that -- Docker metrics, is going to do something really key. It is now going to pull down Prometheus, Grafana, and a graphite exporter. It's going to pre-configure that, load it all up in Docker. So it's all going to be hooked up in everything, right? So if I take a look at my Docker, I have the graphite exporter, the Prometheus, and Grafana. I did not have to do that. That one command pulled that down for me and did that. And here is, dun dun dun, let's see. Now, there will be lag, by the way. And I see some data points starting to come in. Yeah. There will be lag. And as it starts to go through, and there, see, it did its ramp up my schema. Here we go. We're going to start to see some data come in. All right. Now, obviously, you need to give it a couple moments or a couple minutes to really get going, right? And I'll let this run here for a moment. But you'll start to see the data start to trickling like you are now. And that's, I mean, we're going to explain the metrics and everything, but I just want to point out, especially for those of you who, you've experienced Prometheus and Grafana and other tools in the past, they're actually awesome tools to be able to scrape the data out of your system and then visually represent it and everything. But it's not that easy. If you're just starting from complete scratch and you have to install all those tools, you have to learn how to hook them up, you have to learn how to get the data out. This is all being done for you with that one command, right? When I first did this the first time with NoSQL Bench, I was like, oh, that's awesome, because I can just get right away into looking at my performance benchmarking data. I don't have to muck around with these other tools if I don't want to. And so you can see now I'm spitting out the data every 15 seconds as we configured right here. And then the metrics data is actually going to Prometheus and Grafana. Alrighty, we'll give this a second. While that's loading up and while we're seeing some data, I'm looking for questions. Let's see. Oh, Eric. Oh, Eric made it to the leaderboard. That's funny. Yep, we still have more questions to come, that's for sure. Is cycle rate
different?
Yeah, is cycle rate different from cycles? What do you think, Shuki?
Absolutely. So we talked a little bit, very briefly, about deterministic operations or determinism. And I don't know if we'll have time to fit this in, but if we do, we can come back to it, David, talking about determinism and how that relates to randomness in the testing setup. But cycles is essentially a specification for your test session, actually for the activity that you're running. It says, I want to run this many operations. And in its most, in the fully qualified form, it actually says, I want to run operations specifically for this range of numbers on the number line. So it actually is a cycle. Each time an operation runs, it has a piece of seed data that is used to construct all of the, select the statements, construct the data to generate and be injected into that statement to become an operation. And the cycle value is actually the seed for that operation. And by saying cycles beginning and ending, you're telling it the range of seed values to use to generate operations. It's a direct mapping, and if you use the same cycles, the same setup, you'll get the same operations. I'm sure that'll generate more questions, but we'll answer them.
Yeah, and something to point.
Cycle rate is, sorry.
Yeah, go ahead.
Cycle rate is basically a real-time rate limiter that limits the initiation of an operation so that it does not exceed the cycle rate on an ops per second basis. And cycles is how many total to do.
Okay. We have some questions that came in as well. One, any metrics on garbage collection, right? And I would say from a GC standpoint, unless you're going to correct me, I almost called you Shuki. From a garbage collection standpoint, are really going to be on your cluster itself, not out of NoSQL Bench. Would you agree with that, Shuki?
I would agree with that in general, and the reason for that is the way that NoSQL Bench is generally built internally is that it pre-bakes, it pre-allocates, pre-initializes as much as possible so that when the stuff I just talked about, taking that cycle value, plugging it into the statement selection, getting the data generated, that is all designed to be very efficient, and it does. The client will turn over some heap as it does it just because it's generating data, but it's generally not a constraint, especially since, for example, with the NB binary, which is basically it packages its own runtime. We have more modern Java runtimes in there with more modern garbage collectors, and it generally is not a constraint. So if you find that you're having GC limits on the client affecting anything, you probably need a bigger node because you're probably running a small node. That's historically speaking. So if you want us to track GC stats and report them as metrics on the client side, we can. But that also brings up another point. This is a client-side testing tool. It shows what your application would see. It's the most conservative vantage point within your topology to measure from because it's all the stuff included. It's the transport, it's the driver, it's the server, it's the disk access. All that's included from the client-side measurement perspective. Now, if you want to measure server-side things too and even have them in common views, there are ways to do that. It's probably out of scope for this session, but there are ways to do that if you want to. If that's something you really want to do, again, join the NoSQL Bench Slack. We'll make sure there's a link in here for that. But those kinds of things, we definitely we want feedback and requests on them, and also contributions. But feedback and requests is a starting point. So yep. Hopefully that answers the question.
Yeah, and I see some questions coming in. One in particular, Ablesh in Discord. How does service time distribution different from optries? We're going to get there. I'm going to explain all these charts, so don't think I'm just throwing this at you and we're just going to move on. We will talk about those. They are also, all the explanation for all of these are not only in the GitHub and the KataCoda, but something I've hidden is in the dashboard itself. You'll see this NoSQL Bench metrics guide. All of the explanations for every one of the charts is there. But I will go over these so you'll understand what they are. We're not just going to leave you there.
We got one on YouTube here. How frequently would you do performance bench for every step in development? Yeah, Shuki, do you wanna take this one?
Yeah,
that's a good one.
Well, it's like testing is a very broad topic in terms of the why you do certain kinds of testing, unit testing, integration testing, performance testing, scale testing, capacity planning. There's depending on what hat you're wearing, you have a different reason for doing it. So I think it depends on that. What I would generally do is say do prod-like testing before you go to prod. So using congruent hardware, maybe not the same cluster size. I mean, we have something we call scaling math that allows us to do realistic testing on smaller clusters and extrapolate pretty accurately with this toolkit. So so if you're not doing testing before because you didn't have tools that made it possible or easy, then that's no longer really a constraint. So for the very minimum would be to do some capacity planning based on taking the operations and the access patterns and the kind of a sketch of your data, using that to help you decide how big of a cluster you might want. Bookmarks, bookends, like minimum and maximum. Just try to get a good ballpark so that you're not trying to manage scale in situ for the first time on a new cluster. That's an acquired skill set, right? You want to develop that skill set by actually exercising the workload on a real cluster of some size and then extrapolate that for production. And so that's the very bare minimum I would say. Do that before prod. Congruent hardware, smaller cluster, realistic workload that looks like what you're going to be doing in prod. And I would work back from there. The starting point would be using it for functional experimentation to learn about how to do efficient indexes or things like that. Use it for testing your data models, for trying different approaches. There's just a lot of different ways you can use it. You can use it to teach people about data models. I mean, there's just a lot of different ways you can use it. So first, pre-prod testing for scale, and work back from there.
Yep. And I do see some other questions that have come in. I'm going to move from some of them for now, just because we are going to address them as we go through some of the material. Also, don't forget that at the end, we will have that extended 30 minutes for an AMA where you can ask us anything, because I do want to make sure we get through some of the content and everything. I think Tri was asking, where Prometheus and Grafana, and they're here in Docker. That's what happened when we used the -- Docker metrics. It had loaded those up into Docker containers, and that's what we're using here now. But like I said, I do see some other questions that came in. Right, how to decipher the charts. We're actually going to go through those. I'm going to show you all that, so we will get to those. Alrighty, so moving on a little bit. So I'm going to leave this running, by the way. I'm just going to leave this running, let this thing do its thing. Now, in this case, notice that I already had, I cheated a little bit. I already had Grafana and Prometheus running. You'll notice here in the repo, we do tell you this, right? We tell you go to localhost 3000 for Grafana and localhost 9090 for Prometheus. So that is here in the instruction. The first time that you go in, Grafana will ask you for username and password. It's admin. It's right here in the instructions as well. So I'm just going to skip through this piece because we've essentially done this, right? It's just getting you to the point where you're seeing this chart is what that's doing. Okay. So now going through the actual metrics themselves, some folks were asking, well, what do these mean? Another question that came in was, what are the sweet spots, right? So now some of the sweet spots, by the way, depending on what you're looking at, are really going to depend on your particular requirements in your application. But there are some here that are, I think, pretty standard. Ops and successful ops, if we start there. And again, don't forget that we have the metrics guide here that does explain it, so you can always look at that. But for each of those cycles, right, we're going to have an operation. That's some query or some operation. And so we're comparing the total number of operations compared to those that were successful. Now, in a healthy system, these should be equal, right? Notice that both of these here, in this case, at least per time tick, are 100, right? These should be equal. So if you are seeing any kind of deviation here, if you're seeing a lot more ops than you're seeing successful ops, there might be something to take a look at. And that ties into error counts. Error counts always should be 0, right? You shouldn't have errors. If you see any error at all, that's something to investigate. And as a matter of fact, if you do see errors, then you should probably see a deviation in your ops and successful ops, right? Because now I have a case where I have a certain total number of ops, but if I have errors, then not all of them were successful, right? So there is a relationship between these two charts. Service time distribution is really kind of key and very interesting. This is not just response time. It's not the response time of what the query took on the server. That's why it's called service time distribution. This is actually, and this is something very key about this, is and one of the reasons why when you're running NoSQL Bench, you should really run it at the same layer that your application is running as well, right? So if you've got let's say you have some bare metal that you're running application instances on, or you have cloud instances that you're running application instances on, you should really be running NoSQL Bench from that same exact layer, because you want to mimic the experience over the network, the hardware, and everything that you have from your application to the server and back. Why? Because service time distribution is measuring that response time, not just at the server, but from the time it takes to issue the request, the operation from your client through the driver to the database and back. And the reason why that's important is, if you think about it, you could have wonderful response times on your server, right? But if something else was happening in that path, and that's what your users are experiencing, maybe they're not actually getting that wonderful experience. So you want something that's going to be as close to essentially the end result, like what you expect your application to be doing. So that's where service time distribution is important. Now, in this particular case, for our metrics here, I'm only seeing a deviation of I see some that are kind of ramping up to like a second for a particular operation. That might be something that I want to take a look at. As a matter of fact, if you know service time distribution, if you look below it, service time range, this is really showing you what are the min and the max, right? These are giving you the extremes. So you'll notice that you see this 1 second outlier here. Well, that's showing up in my service time range as well. So Shuki, is there from your from your viewpoint, I think so much of service time distribution is going to come off of what a particular implementation's requirements are. But as far as like a gold standard or something, is there some number or something you're like, wow, if you're seeing that, you really need to check this out?
I would say it's very situational, because in the toolbox of all the things we have to build distributed systems out of, there are extremes in terms of performance. So, for example, if you're building a database with some type of network between your host system and your storage device, you're in a totally different ballpark.
Right.
But people will do that with certain workloads that are not affecting their users with interactions. They'll do that for things where they can get away with it because maybe it works better for them in terms of management or cost or whatever. But for performance, you generally want to keep your storage local to your database nodes, right? Ephemeral. And so there's a whole different spectrum of requirements depending on what you're actually trying to accomplish. So I would say if you're talking about a typical system where you're using local storage, you're not using Rust, you're not using remote block storage, for example. It's just the classic, shared nothing type of setup that you would normally use with a distributed database. Then you can do basic operations reliably under 50 milliseconds or 20 milliseconds or 10 milliseconds, depending on the complexity of the operation. And it's really going to depend on the hardware, the infrastructure, and the kind of operation you send. I've seen, even many years ago, we crossed the threshold of going down below 1 millisecond. There are many cases where you do operations measured in microseconds.
Right.
But meaningful workloads tend to have operations that are more interesting, have more interesting predicates, more interesting data. And when you get to a volume of data on the server side, you're going to see that the character of the response times expand out, because that's just the nature of random access on any system, is that it has a lookup cost to it. And the best algorithms we have in the world can't get over that hurdle.
Right.
There's no magic.
So would you say that it would be a true statement that for something like service time distribution, if you have particular requirements in your application, like if you have a requirement that an end user gets a response within 300 milliseconds or something like that, that you're pretty much, that's what you're talking about, you should be looking at in your service time distribution?
Yes. So we're not talking about the connection between the user and the data layer, right? There's a couple layers there beyond that we're not factoring in. But we're treating the application kind of as the demarcation point here, because that's one of the most operationally useful vantage points, because that's where we do most of our tuning. That's where we have most control of things. And it's inclusive of everything. So the service time distribution from this perspective tells you if you need to do something about your hardware, your data model, or whatever. It's basically the canary in the coal mine. It's this little sight glass into the system that says we have a problem or we don't have a problem. And it's the best place to gauge the requirements in contrast to what you're actually achieving with your workload, your scale, your infrastructure, etc.
Okay, cool. Thank you, Shuki. Okay, so then moving on then to opt-tries distribution. This is one of those, though, that you could say that does have kind of a range of values that are kind of the standard, right? Essentially, this means how many times per operation did I need to try that operation? It should be one, right? If my system is healthy, I should only need one try for an operation to complete that operation. However, if my system is overloaded, maybe I'm getting timeouts or something like that, it may mean that for an individual operation, it has to try more than one time. So I would say in this case, if anything other than one, you should probably take a look. If you ever get to something like an opt tries at 10, your system's probably on fire. You need to stop what you're doing and you need to get over your cluster and see what's going on, right? So this is definitely another one of those that I would say is probably another canary in the coal mine, right? The opt tries distribution that gives you that feel of, hey, if you're deviating from one, something's going on.
This is a really interesting metric because it does provide a level of nuance that a lot of metrics can't. And the reason for that is it measures when everything's great, it's a flat one, right? When one thing goes wrong, then the histogram shifts ever so slightly. When some things go wrong, it shifts a little bit more, and the way that the scale of the values in this picture change provides it's a very wide, what you would call a wide dynamic range of interpretation about what's going on in your system. So definitely, if it's all 10, everything's broken. If it's all 1, everything's great. And there's just a lot of room for interpretation in between those two extremes. It's a very high value.
I would be surprised if you actually had an optimized distribution of 10 consistently if you weren't seeing a bunch of errors and your system's on fire. Your system's on fire at that point. All right, so then moving down to the P75 client overhead and the P99 client overhead. Those things are really measuring the overhead of NoSQL Bench itself, right? These should be very minuscule and almost negligible compared to the operation of your system. They're here just as kind of a litmus to ensure that that's the case. If you notice that both of these are in the microsecond range, right? There's extremely low overhead of NoSQL Bench. They're just there as a check to ensure that that's the case, right? I've never seen a case. I don't know, Shuki, if you guys ever have. I've never seen a case of either one of the P75 or P99 client overheads ever deviating from this. Do you know of any cases where that can happen?
Not really, and the reason for that is probably the most variable thing that we do in terms of client-side processing is generating data, and why that could be variable is that maybe sometimes you generate data that follows a distribution where 1 out of 100 times it's a fluffy bit of data, and the rest of the time it's not. So there could be some variance in the data you generate, but in general, the data generation algorithms we use, this is one of the more fun aspects of building these things. The data generation algorithms we use, we always shoot for using an O1 algorithm. So we even are able to do things using something called alias sampling. We can simulate sampling from US Census first and last names in O1 time using discrete weights as they were seen by the last census where they published those names. And that's because we do the research, we do the we do the computer science behind making these algorithms work that way and building them in as easily hoistable functions in your recipes. And that's why these lines are flat, because we don't play around with the data generation, because we just want it to be really fast. By having the client be really fast, we increase the dynamic range of what we can measure accurately in the system, because the client is getting out of the way and focusing on the work it's doing instead. Or the NoSQL Bench core, I should say.
All right, thank you. So I'm responding. So I'm sorry, my keyboard's like super loud. Okay, and then we did talk a little bit about service time range. This is really just the extremes, the min-max of the service time distribution above it, really helping you see the outliers. And then last one is cycle count. So if you remember before, when we ran our command, I think I quit it. Yeah, I quit it a little bit ahead of the time. But we had, let's see, one of the other ones we did, where I had 100,000 cycles. So if I set something to 100,000 cycles, if I let it run for its, for the full thing, I would expect that I'd have 100,000 cycles, right? This is just letting you know where you are in the amount of cycles, the amount of operations that you have run per the performance benchmark. Okay, so with that, what I'm going to do here is hopefully we kind of broke those down, each of them for you, and gave you a little bit better idea of what they're looking at. This is all actually explained in the GitHub repo. It's in KataCoda. It's in the NoSQL Bench docs. It's around. You can always ask us questions, right? So always feel free to ask if you're still not clear on something. So that's this section here. I'm essentially going to scroll past all of this because it's really just the explanation of what is going on. The next thing I'd like to do is just look at Prometheus for a second, right? At this point, if you've been with us, you've probably seen some of the Prometheus pieces. If you're not, then this is the tool where Grafana is the one that we're using to visually report and display the metrics and do the analysis. Prometheus is the tool that we are using to talk to NoSQL Bench and scrape the data and pull all that into Grafana. So you'll see here, again, If I go to the localhost 9090, that is provided right here in the repo itself in the instructions. That'll bring me, all I did, the only difference is I navigated to targets already. So if I pull this back, this is what you would look at first. I was just looking at targets to make sure they were good. But what's interesting here is this insert metric at cursor. If I click on this, you see these are all the metrics that are coming into Grafana from NoSQL Bench. That's service time. We were just talking about that. So you see this cycle service time. If I execute this and then I graph it, you'll notice that data should look really familiar, right? So yes, can I graph? Can I do some of this in Prometheus? Yes, you can. It's not from a visual standpoint, right? It's not nearly as you can't do the same kind of analysis. Not nearly as pretty either as Grafana, right? But that's not what it's for, right? It's really the tool that's scraping the data, that's pulling it in and providing the plumbing to get data from, whether, by the way, this could be your nodes. If you're using Cassandra or DataStax Enterprise, you can use the Prometheus and Grafana setups that we have for those as well, with the metrics collector and collectd to pull this data in. So just kind of unveiling a little bit that underneath the hood between NoSQL Bench and Grafana, we do have Prometheus, and that's where the metrics are being scraped and pulled in. And so this whole section, that's essentially what that's going through. So I'm just going to skip down because that's what we just did. With that, let's go ahead and get to our next quiz. Quiz time! Next quiz!
All right.
Let's see. Oh yeah, by the way, please wait on the KataCoda scenarios until after. That way we don't have everyone hitting it at once. Let me see. I do see... Yes, and by the way, if you do load KataCoda, KataCoda will stay, I want to say those instances stay going for about 30, 40 minutes if you leave them running. They eventually will time out and die. The cool thing with KataCoda, you just restart it, right? It'll spawn up new instances for you, and you can just do it. And since all the stuff that you're really working with is meant to be temporary anyway, it really doesn't matter. Alrighty, so I saw a bunch of thumbs up here. I'll wait for a bunch to come in. Alright, I know, let's see. All right, for those of you who want to get into some swag, are you ready? To enable visual metrics in Grafana, use --report graphite 2 -- display metrics -- Docker metrics. This is easy for me to say. Make metrics so easy I don't need to care. And yes, it's -- Docker metrics. Yeah, that's probably a little tricky with the display metrics one. Funny enough, report graphite 2 is a command you can use. It's just not the one for this. All right, so that was that one. Let's see. How did it go here? Dun, dun, dun. Okay, so TDH stays on top. Massey and Jeppreet coming up in number 2 and 3. Let's see what we have in this one. Grafana is the only way to view performance data. Again, look at your phones. Is that true, false? Why is there a third option in a true and false question? That's a good question. All right, let's see what happens here. That's right, false. It is not the only way to view performance data. I have seen some questions that came in earlier with regard to some other tools you can do. I'm going to ask you to wait for the Ask Me Anything at the end, and we can get a little bit more detailed answer on that. So Grafana is not the only way you can view performance data in NoSQL Bench. And TDH, is staying on top. Massey, look at this. We've got this top 3 that's... Yeah, but TDH is really just holding it here. We got to find out who that is. Well, okay, we'll see if they continue, if TDH continues to stay on top here.
Right. There can always be an
right.
upset.
You never know. There's always upsets. How many errors should I expect to see in the error counts metric? About a handful. That's about normal, right? None? 10 to 100, depending on the number of cycles? Or, wait, I need to watch the error count? That's right, none at all. None. If you see any error, it is something you need to go check out. You should not be seeing errors regularly or anything like that. And where are we on the leaderboard? Wow, this is getting just closer and closer. All right, TDH is holding the lead with Massey. Actually, all top 3 are holding it. Is anyone going to upset? Are going to get any upsets today? And what value is normal for opt-tries distribution? 1, 5, 10? I don't know. Didn't read it. Of course, I kind of said it. We did talk about it. Yes, 1. 1 is the normal value for opt-tries. Again, if you see any deviation from opt-tries, right, it means that for a single operation, it had to try more than once to perform that operation, to complete that operation. That tells me that something is potentially going on there, right? For any given operation, you should only need 1 time to complete it. And dun 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 dun. Oh, I don't know what just happened there. Oh, okay. Phew! For a second, I was like, ah! I don't know if you saw that my screen flashed. I thought something...
Yeah.
You did see that? Okay.
Froze for a second there. Yeah.
Oh, look at this. All right, so TDH is holding it. Massey in second, but Jappreet has been overtaken by Rityana. Let's see. We do have more questions. Where does Grafana get its data from in NoSQL Bench? It reads right from the log files, Prometheus, the NoSQL Bench endpoint, or the data ferry. All data comes from the data ferry. I kind of like the data ferry, honestly. Do you guys need to implement a data ferry?
Okay, if you can give us a specific...
you want a PR for the data ferry?
Yeah, PR would be even better.
All right, yes, it is from Prometheus. It does not read it directly from the log files. It is coming from Prometheus. That's the glue between NoSQL Bench and Grafana. All right,
I'll get you that on April 1st.
All right. We could rename the virtual data set stuff as Data Ferry.
All right, let's see what happened here. Yeah, TDH is holding the lead. Massey is close, though, and Jappreet came back. This is like a tight race between the top 3 there. All right, so going into the next section. So I'm just going to click next and go. Now, this final section is the area where we're going to start to break down a little bit more of, if you remember so far, I've given commands. We've seen things like this workload, CQL key value, and CQL IoT. And again, like I said before, that might seem a little abstract. Like, well, what's in there? Like, how's it? Okay, great. You created a table in a key space, but where did that happen, right? I've even seen a couple questions come in asking about that very thing. This is what we're going to address now, right? So we're gonna break through and kind of break down what all of the, like, how is this stuff getting built, and how can you configure the YAMLs and modify it for your system. The first thing I want to point out here is this list workloads parameter, right? So if I run that, you'll see that NoSQL Bench comes with a whole set of standard workloads that you can work with. This is really nice to start from, because all sorts of work has already been done to, say, create an IoT benchmark, or a key value one, or a tabular one, right? And so on and so forth. You'll find someone asked an Astra question earlier, that within many of these, you'll find that they have Astra options as well, right? Because there are different operating parameters for something like Astra compared to your your hardcore DSE or Cassandra cluster. But the cool thing about it is you can just list these out. You can see the ones that are embedded inside of NoSQL Bench, and then use those if you want as a starting board to get going. Now, scenario or workloads are like the whole thing, right? So if you notice that in some of our workloads, we're doing the schema phase, ramp up phase, and main, and it's got like all the stuff in here. Scenarios are another component of workloads, right? So within a workload, you can have what's called a named scenario. So if you use the -- list scenarios -- command, dash is very hard for me to say apparently, you'll find that it's going to start to give you a little bit more information. It's going to break out some of the underlying details that are in the scenarios in a particular workload. Now again though, you might look at some of these and go, well, where is this coming from, right? Where are you getting this from? And that's what we're going to go to next. Let's see. Okay, I was just looking at some of the questions. So again, these are just, utility commands that allow you to list out the various workloads and scenarios that are included inside of NoSQL Bench that you can use to copy from, hence the next section. So what we're going to do is we're going to copy a workload. So this is actually really cool and very powerful in my opinion. I can take any of those workloads. If I take the SQL IoT one, for example, right? I've got SQL IoT, I've got this workload in here, and in my directory, I've got NoSQL Bench, I have the logs that I've generated, but what happens if I want to start creating or modifying a workload that we've used previously? I can just copy it. I love this command because it's so simple and it's really powerful. So I'm saying -- copy. I want to copy the SQL IoT workload, and now notice that I have a SQL IoT YAML, right? Now, here's where it gets fun. So I'm going to go ahead and look at this in an editor. On first glance, if you were to take a look at one of these files, especially if you're not familiar with YAMLs, and you were to like go down here, it'd be like, whoa, like there's a lot of stuff in here. Do you expect me to just understand everything that's going on, right? Especially too when you see things like, what does template mean? What are these, what are the greater than and less than signs about, right? What's going on with bindings? What is all this, right? So that's kind of a lot to grok right off the bat. Just understand underneath when you're issuing a workload, when you're running one of these things, it's comprised of all the components you're seeing. So what we're going to do, instead of starting there, we're going to start the other way around. We're actually going to start with nothing and build it up to help explain all the underlying sections. So this makes a little bit more sense. Okay. So what I'm going to do is I'm going to give you an example. Now, one of the things I'd like to point out, if I go back here, is, again, there's all these like special characters that are being used. I'm getting to a spot so I can show you something. Right. So if you notice something like this, right, you see I've got curly braces here. I've got my greater than less than symbols. I've got all these little kind of special characters that are in here, or template, for example, right? And at first glance, you might not have any clue what those are doing. What's really cool, though, about NoSQL Bench and the way that it works is all of those things have been added in as you'll see as we build it up to essentially add more power, right? To add more capability to what you're doing. But you don't actually have to add them. As a matter of fact, pretty much everything in these files is optional. So let's take a look. So what I've done here on the page, and again, you'll find this in the KataCoda scenario. You'll find this here in the repo. But what I've done is I've essentially taken the same IoT workload that is in this file that we just copied, and I've broken it down, and notice that I've ripped out all the special characters, right? So if you take a look at what this is doing, this is our schema phase. What might I do in a schema phase? I'd create my key space and I'd create my tables. No different from what you would do in CQL if you're working with your own database. So if you'll notice that I have my DDL for my key space command, and I have the same thing for my create table, right? This should look no different from how you would go about doing that in CQL for your own key spaces and tables. So at its base, separating out the YAML, all I'm doing here is I'm setting up a file that I'm going to use to essentially create my schema, right? Create my schema and clean it up. If you're familiar with like stuff like this, now in this particular case, since we are using an IoT workload, there are TTLs in the data set and such. We are using a different compaction strategy. But do I have to put these in? No, I don't, right? It depends on the particular configuration of my table, what I'm doing, my data model. In this case, we have them because we want to use a different compaction strategy. So again, note you could even pare this down even more, right? And just provide this without the rest of it. But again, this is no different from your regular SQL commands that you'll use for your key spaces and tables. So let's take this file. Let's break this one down. At the very, very basic, I have the first thing in here is my description. Description is just given an explanation of what is this particular workload doing, right? This is nice, just like comments, to give yourself and other people who are looking at the particular file an idea of what this is doing. So it's letting me know that, hey, this workload is about time series data model creation. Now, the first thing I want you to notice here, and this is part of the YAML configuration, right? Someone asked earlier, where do the tags come from? How do I know what this is? And if you remember in one of those commands, if I bring it up, let me get out of the file here real quick. And right. Remember this? Tags phase, main. We had ramp up and schema. That's what's happening here. So we're creating a block. And within here, we're just saying phase, what the phase is. Now this is going to define, so when we set this up, if you remember from up here, notice I have this block phase schema, and then within it, I have a set of statements, right? So this, when I am issuing at the command line, that parameter, that tags equals phase colon schema, I'm saying, do this. I'm saying, do the stuff that is in here in the schema phase. That's what that means. Now, if I scroll down a little bit, notice also that then I get to the param section with statements. Now, prepared, is it a prepared statement or not? Right? Since this is schema creation, this is not a query I'm going to be running over and over and over like thousands of times or anything. No, I don't need to prepare it. If I was running insert statements or select statements, and that is when I'm regularly benchmarking, the same kind of thing that we would say in your application, you want to prepare those statements. But in this particular case, it's a single run, so we don't really need to prepare it. That's all prepared is. It's just saying, is it prepared or not? Do I need to include this? No, I could simply not include it, right? But again, because I know what a prepared statement is, I'm adding that in there. So these things are all optional. Optional. I just said optionable. New word, optionable. All right. So then within here, then also I'm going to look at my statements again. I'm just saying here I'm going to create my key space command. That's what that command is. I'm going to create my table, and I'm going to truncate with truncate table. Again, just normal SQL. Now, if we move on a little bit, notice this next one. I want to point out that it's the ramp up phase, right? Now, each one of these, I just want to point something out, by the way. If you wanted to, and this is in the repo. What I'm just about to show you is in the repo. And let me blow this one up too. Okay. So all these files are being provided for you. Notice here I have a whole set of files that are named things like SQL IoT basic ramp up. So this is actually another reason why above the description you see this right here, this first line is showing you how do I run this, right? That's just a standard. You don't have to do it. That's just a good convention. So that way, if you're ever looking at this, you want to know, well, how do I run this? Well, here's how you could run it. But I just want to point out that I've broken these all down. So in the repo and in the KataCoda and everything, you have these individual files, right? So this one here, if I were to take a look at it, you see I've got this broken down in here. And this is just a ramp-up phase. So I've actually got a single ramp-up phase in this one file, which is why I called it basic ramp-up. Now, in here, there is something a little bit different going on with these bindings. I'm going to skip over the bindings for a moment, and I'm going to go to the statements. All this is in the ramp-up, well, I want to insert data into the system, right? So I need to issue the CQL, the insert statement, that is then going to get that data into my system. This is just a normal insert statement. There's no difference there. So for your data model, you would use the insert statement you need to get data into your table. Where the difference starts to come in are these curly braces. Now, could I hard code a bunch of values into my values? I could. That'll totally work, right? Matter of fact, when I started building some of this stuff, that's exactly what I did. I just used hard-coded values that I knew worked because I wanted to get it all working, right? And then I stepped up to add in my bindings. The bindings, we're not going to get into a lot of the detail with the bindings today, but the bindings are the key. I've seen a couple questions that have come in about, well, how do I generate the data? How do I insert randomness into my data? How do I do that? That's where the bindings come into play. right? So if you take something that's pretty simple to understand, like sensor name, within the SQL bench, there's actually a text file stored within it, where it has a set of words that all represent potentials for sensor names, right? And so it's literally reading from a file. You can provide this for your own data set as well. So it's a seed. It's a seed list of data that you can use. Things like, you'll notice data here. If you remember some of the data that we had, if we take a look, if I open this one back up, if I say select star from IoT, or there we go. Okay, so notice, okay, so if I take a look at what this is, like machine ID, right? That's a UUID, here's a UID. Sensor name, right? I'm pulling from variable words, so I've got these variable words that show up, right? The next one's gonna be time, so I've got a date going on, right? This data here is, again, I'm pulling from, if I know I'm gonna have like paragraph-like text, instead of trying to come up with a bunch of paragraphs and store that or something, you can use something like this that will generate, even though it's gibberish, it'll generate something that is gonna feel like the kind of data that you might have. So the point of these bindings is to then create essentially that data set and generate what that data is going to look like, and that's what is getting inserted in. So later on, if you notice machine ID is my binding, and that's my UUID I'm using for an ID, well, here's my machine ID, and then I just say curly bracket, machine ID, curly bracket. That is binding, that is matching to that binding, and so it's going to use the binding for that data, right? Same thing with sensor name and all of these. So it's really easy. Once you figure out your bindings and you get those going, right, then the rest of it is honestly pretty easy to hook up. Now, Shuki, yeah, go ahead, Shuki. I was going to ask if you had any more on that one.
It's a good time. Yeah, there are a couple topics here, and please hit the timer buzzer on me.
I'm kidding. I'm kidding.
So there have been a couple questions about using real data, ML-generated data, that kind of thing. And yes, you can do this kind of thing. But there's one working principle that I think everybody really needs to be aware of. This is proven out experimentally and practically with many different approaches to try to test this. So this framework, this toolkit that we have here, we didn't just create it and say it's good. It actually went through several different iterations of trying different ways of making it work well. One of the lessons we learned from that is that piping around bulk data to get high fidelity measurements from a system, not feasible, not practical for most cases. And just to kind of anchor that in a little bit, I'll talk about a couple specific things that kind of make it make sense. One is, if you're doing ETL jobs to test your target system, your client system needs to be at least as powerful, if not more powerful, than the system you're testing, which brings in a whole other aspect of management operations, data management, versions. It's high. It's a high mass type of problem to deal with. So that means that you don't actually have the flexibility of changing this synthetic data, because you got to use the real data every time. At the same time, we don't want to have fake data all the time, right? So there's a happy medium in the middle. We've learned that data generation, when done right or well, is extremely efficient on the client. That's why we saw the P75, P99, or whatever the P95, the levels for the NoSQL Bench internal, that flat line. We figured out how to do that really fast. Right. And not only do we eliminate the problem of having to pipe around hundreds of gigs or terabytes of data to have something that meets the scale of the data set we're trying to test, we avoid that problem entirely. Now our client has all the resources freed up to actually, the core of the test engine, it has all those free resources to actually run the workload and measure the workload in a reasonable dynamic range. So you get more accurate metrics than you can if you're piping around bulk data. So what we do is we take data from sketches of what we see in production, from production extracts, and we provide them in CSV form to the client, and we let it kind of fill in the rest for us.
Yeah.
We can approximate the statistical distributions in O1 time. We can sample realistic data in O1 time. There's some really cool stuff we can do in the data generation that gives us back a really efficient test client that isn't bogged down doing I/O and context switching and flushing memory all the time. So that means we have an accurate test instrument, because the basic principle here is that the test instrument has to be more capable in terms of its effective scale than the system under test. Because if that is not correct in terms of relative work on both sides of the equation, you're only testing your test system. You're not testing the target system.
Right.
Think of the analogy as a stethoscope with a buzzer in it. It's useless. You have to take that extra burden out of the system to be able to see what the target system that you're trying to test, right? And that's the principle behind the procedural data generation and why we do that. So this is all kind of a cautionary tale to say, don't try to bank on having, quote, real data through and through. For practical reasons, there's a need to kind of distill that out into a data shape, as we can call it sometimes.
Yeah.
A data shape that is representative of your data set, that you can go do a 1 million row test with, or you can go do a billion or a trillion row test with. The limitations are really in how big of a test you need to do. At that point, if you need to change a data set, you change the recipe, and it's almost like you just magically morphed a terabyte of data, because it's virtual and it's procedurally generated. You hit the go button again, and you basically have modified your test with just a simple edit. So that's just a little bit of a grounding as to why we do it this way, and why at least we think it makes sense for NoSQL Bench.
Cool. And by the way, I did see a couple questions. I think Eric was just about to ask one.
Yeah,
I heard him breathe in. I did see one, though. Specify pseudo-random seed. And what about benchmarking your existing data? Wonderful questions. I want to reserve those for the AMA. I know that we're coming up to time. I do want to finish up. We're going to go a couple minutes over, not too far, but then we can really push some of those out, because I think Shuki's going to have some wonderful answers for you, and they're more in depth.
And we'll answer all the questions.
Yeah. So that was TDH. I don't know who asked the one about benchmarking your existing data, but yeah, let's address those in the AMA. Okay. So again, and what I'm probably going to push you about 10 minutes over, right? I know some folks have a hard stop. You can always watch these later, and it's all in the KataCoda and everything. But I do want to get through that, and we do have that last quiz. So I want to kind of push through to this last piece here, and then I have something really cool I want to show you as well. So for this here, again, we just created a file that is representing our ramp-up phase. Again, the one difference here are the bindings. But once you've got those set to help generate your data, then you can just bind them into your insert statement for the ramp-up. Again, you'll notice the same thing here. I talked about that. And the last one here is main. So I've created 3 different files, each of them that have different phases, right? This one is main. Again, you'll notice I have just a couple bindings needed for my statement. And then this is just my regular SQL statement. And again, using the curly brackets to bind to my bindings. Now, something I want to kind of explain here is that, could I do it this way? Yes, I could actually run every one of these just like this, where I have a separate file for each one of these particular phases. I could absolutely do it that way. Now, NoSQL Bench, though, will allow you to combine that all into a single file. And that's actually what we saw when we first looked at this, when we first copied the IoT workload, the CQL IoT workload. That's what we were seeing. We were seeing the whole thing that was in one big file, right? But like I said, that could be a little daunting at first. So what I did is I just broke it down so each of the phases are in a single file that is kind of a little easier to digest. So now what I'm doing is I've essentially taken, notice I've got 3 different runs, but I want you to notice something kind of subtle. Notice here in what we did before for my workload, I was specifying a different YAML file for each of the workloads that represented each of my different phases. But in this new file, I have a single file that includes them all. And notice that the YAML file is the same exact YAML file, but now comes into play that tags equals phase schema. So one more time, let me go back. Notice in these commands, I don't have tags equals phase schema. I don't specify the phase here because I separated them out into different workload files, essentially, right? But now that I've combined them into one single large file that has my schema phase, my ramp up, and my main, now I can reference them in a single workload, and then I can just call them specifically by their particular phase. So this is where you're kind of essentially breaking it down. Okay, I've got these 3 different phases, but I can combine them into a single file here. And now this is the same thing. This is the same thing we just went over. The only difference is that I've combined them into one place. Now I can reference them in one place. Where this starts to get really powerful and really cool is then what you can do with named scenarios. So I'm going to add on one last little piece. Now, by the way, in the KataCoda scenarios, when you go to do those for homework, in the third section or whatever, you will break down through all this and you'll build these up. And the nice thing in KataCoda, they make it very click. You literally click on the pieces and you'll see it build up as you go. And I'm trying to go at a pace so people can kind of understand what I'm putting together. If you're finding you're like, I'm not quite getting it, trust me, go through the KataCoda scenario. I think it's gonna help you kind of build the stuff up physically. So this last part here though is where we add in name scenarios. So I'm essentially going to take that single file, that single workload file that had my 3 phases, and I'm going to add this scenarios block right at the top. What I want you to notice is in the scenarios, I have what's called a name scenario. So this is the default scenario. And now look at some of these parameters should look familiar. They should look like some of the command line parameters we've been running at the command line. Well, NoSQL Bench will allow you to set those right there in the workload itself. So I'm actually saying I want to do run, I want to use the CQL driver, what phase, how many threads, so on and so forth. If I then put that here at the beginning of my file, then later on, again, the rest of this is the same. This is the same file we had a moment ago. Then now I can actually run this as what's called a name scenario. And when I do that, it actually will run all of the things within that scenario with all of the settings that I have just given it. So where you've seen me running things like these commands, where I'm actually specifying the phase and how many cycles I want and what driver, I can just specify that right in my YAML file. That is how, if you remember in the very beginning, we were doing things like this. When I did this, if I could type it, and you're like, what's going on here? This was actually running through. Now, since I didn't specify anything else, it was just running the default scenario. This is actually running through everything that we see here with those particular parameters, right? So you have the ability, you have the flexibility to, if you want, you can actually, run with all sorts of the parameters there in the command line, or you can encapsulate all of that right there in the YAML, run it as a name scenario, and literally just run something like this. What's really cool here too is that this allows, can you imagine for a moment, you have maybe some of the parameters that you don't want changed, right? There might be some things you kind of want to lock in. This will also allow you to do that and ensure that on subsequent runs, they're being run the same exact way every time without any adjustment on the parameters. It's getting into a little bit more of an advanced case. Like I said, we're just scratching the surface of what NoSQL Bench will allow you to do. But this, if you were wondering, how do we start with something so abstract with that CQL IoT, and then it ran all that stuff? This is essentially how that's being put together. Yeah, Shuki, do you have something you want to say?
I mean, just to solve one of the key problems we have in one-off testing efforts, and that without some type of automation, you never know that you're actually repeating the same test over the course of the testing endeavor, right? This completely solves that problem. It codifies what you're doing, how you're parameterizing it, and lets you hand that file over to a coworker, colleague, or collaborator, and they can just do exactly the same thing. It's a immediately portable workload. And so you can put whatever parameters you want to in there, you can lock the ones you want to lock, and you can make the other ones modifiable. You can change things on the command line if you want.
All right.
So there's one more
yeah, go ahead,
detail.
Shuki. Yeah, go ahead.
This form was the first form we added for named scenarios. If you want your metrics to show up in the dashboard that are step-specific in the named scenario, all you have to do is change those list entries from dashes, give them names like a map. It's an ordered map. It'll automatically plug that name into the metric name, and you'll start seeing them pop up in distinct ways according to the step name.
Oh, that's cool.
So that's maybe something for later, but if you want to see that in your metrics, know that it's there. It's in the docs.
Okay, wonderful. All right, so for the rest of this, now, by the way, when you follow the GitHub repo, if you follow the KataCoda scenarios, it's actually stepping you through running these individual files. You can see I'm skipping that for now because we are technically over time. So here's what I want to do. This is something fun. So I set something up terrible on purpose. So let me actually show you what I've done here. Here, I'll kill these because they don't need to run right now. So I created another scenario where I created an anti-pattern. And I do know that I need to probably blow this up. Let me blow this up. Let's see if I can't get this to... And I can stop this one. So what I have here, I have two things going on. I have an Astra. I have a free tier Astra. That's the one that was running on the left-hand side. And then I have a 6-node Cassandra cluster that was running on the right-hand side. At the same time, I was running an anti-pattern against both of them. Here's what I want to point out here. So I should have, yep, okay. So notice these scenarios. So this is in a single workload that I've created. This should look familiar. It's kind of the one we were just talking about. Now, Astra is kind of a special case, right? Because in Astra, you can't create a key space, right? So if I were to just run the default scenario against Astra, but it tries to create a key space, I'm going to error out. So you'll find in the latest versions of NoSQL Bench, they all actually come with a default Astra scenario. Somebody was asking earlier about how do you hook that up. I'm going to show you. It is so uber simple. But know that if you're going to use Astra, and you can, you're going to want to use the Astra name scenario, or at least make some differences there, right? And you notice here, I actually modified mine. These by default are 10 million. But for my Astra free tier, right? For the free tier, if you're using like a higher tier Astra, then I wouldn't worry about it as much. But for free tier, 10 million rows is going to take a moment. So I decrease this down to 100,000. But notice this Astra anti-pattern. So I created another name scenario with an anti-pattern, and I created another phase called main anti. This is a really neat way you could use to test variations on your data model, right? And because allow filtering is something that we see a lot, I thought, I called it main anti, sorry. There we go. So all I do is create another phase called main anti, but look what I did. I did something terrible, right? So if you look at the main phase, what we would expect, right? Then I have my proper pattern where I'm using my partition key and potentially a clustering column. I actually think this is a composite key in this one, machine ID and center name. That's the way that I would expect that I would get my data out of Cassandra. But in this one, my anti-pattern, what I did is I just said, well, where's station ID, which is not my key at all, allow filtering, right? So the question then is, what would that look like? What would that look like? This is what that looks like. So I was running this in the background while we were talking and everything like that. So what I want to point out is, you see this flat line? I was running the regular main phase like the whole time. And then you saw me switch screens there and I went to the anti-pattern. I just want to point out, this is a real 6-node Cassandra cluster. It is only 667 megabytes of data. This is not large at all. The only thing that I did differently was change to use allow filtering and not using my partition key. Look what happened to my read latency. 6 seconds in my P999s. Even my P95s are just god-awful, right? You can very clearly start to see what happens. What's also note that my reads cluster, my writes, dropped off, right? Where before I had a good clip going, but once the allow filtering piece came into play, that just, there was so much that increased load on my system, and the individual reads were taking so long that it dropped significantly the amount of reads and writes that I could actually handle. This is a great case to help illustrate where if you have multiple access patterns and you want to test those and see what those look like, here's a way you can use the NoSQL Bench to then just apply those different patterns and then look at the data, right? And take a look at the data. And I want to see my Astra one. What's that?
I was just going to say one other point here too. If you were actually watching the metrics from the Cassandra cluster on that end and watching system usage metrics and everything, we would have seen a corresponding spike with the allow filtering.
Absolutely.
It's just goes to illustrate why allow filtering is not a production setting that should ever be used.
Yeah, exactly. So one last thing. Notice that I am in Astra here, and I did promise you that I will show you how to hook up the Astra. I'm going to do that in just a moment. If you haven't played with it yet, and if you are going to do something, especially with NoSQL Bench, notice that when you're in your regular Astra database here, you have this health bar over here. You can just click on that, and interestingly enough, you already have Grafana embedded here, and it's already pulling metrics from Astra. So you do have that ability. That's actually what I was using there to look at. And if you click on this, just like I would in Grafana, you have all sorts of different dashboards you can look at. So that's kind of neat. So again, it's something kind of, if you want to start playing with that, that's something you can do. So I just wanted to point that out. So last thing here, and then we'll stop for a minute and get into the AMA, is this. Someone asked, how do you connect up to Astra? And actually, I should show you also how do you connect up to another database. So far, up until this point, most of the commands you've seen me use, we've been using just the localhost 9042, right? Well, it's really simple. If I want to connect to, like in this case, an external Cassandra cluster, I just add the host parameter. That is only one of the IPs of my nodes. Again, remember, it's using the driver. It's going to gossip. It's going to discover the rest of your nodes. So I only need to really point it to one if I want. And that right there, that's all I needed to do to hook it up to my external Cassandra cluster. In the case of Astra, you know our friend, the Secure Connect bundle. We've been using that. Well, that's all you need. So here it is. I add the Secure Connect bundle parameter, and I just pass it to the location of it. Now, obviously, in my Astra sense, I do need a username and password, so I'm just passing those here. Those should look familiar, those same ones we used before, right? And the 6-node cluster I cheated and didn't have authentication on, but if I did, I would have used, whatever authentication I needed. But that's it. Secure Connect bundle. This is also in the docs, right? It's not hidden or anything like that. But if you do that, you pass in your Secure Connect bundle with your username and password, that's it. You'll hook right up to Astra. Okay, so with that, that is it for the main session. And I want to give a moment before we go into the AMA. I appreciate everybody for coming on today. I appreciate you sticking with us. I know we went 10 over. Oh, by the way, I'm forgetting. We have a quiz to do. I'm so sorry. We have one last quiz to do. I almost ended, and we have a quiz to do. All right, let's finish off and get into the quiz. I can't believe I almost did that. Because we have to get some winners, right? We have to get some quiz winners here.
Yes.
All right, if I could only get Menti to respond. Menti, do it.
And don't worry, everyone. After the quiz, we'll take 5 minutes. Just go get a drink, do what you got to do, and then we'll be back for the AMA. So you'll have a moment here to kind of recoup.
Okay. Yep. All right. I think it got. All right. Well, I'm just gonna have to start. It should have saved the leaderboard. For some reason, Menti was not going. Let's see if this will let me do it. Come on, Menti! Yay! All right. Let's see. I was getting worried there for a moment. Let's see if we have the right questions. Yeah. What command option is used to display pre-packaged workloads? List workloads, all workloads, view workloads. I can read the docs and find out. Correct. -- list workloads. Yay. All right, let's see. Uh-oh. TDH may have lost the top. Oh no. Look at this. But you're still in the third. But Massey, look at this. You just have to persevere, right? You gotta. So Massey and Japrit are 1 and 2. Krishna, I see you there. See you coming back up. All right, let's see. What order should phases generally be executed in? Schema main ramp up, main schema ramp up, schema ramp up main, or liquid gas and plasma? And yes, it is schema, ramp up, and main. Because if you think about it, right, if you go to run a main phase, but you haven't run your schema, you don't have a schema. You don't have anything to insert in there. You're going to get errors and such. And then the ramp up is for the purpose of seeding your system with the data that you need to go into the main phase. So schema, ramp up, main. Let's see. There we go. And what happened here? Oh, I wonder if TDH is going to pop back up. Okay, well, Massey and Japrit. All right, it's close. Here, everyone thought TDH was going to... You can do it. You can do it. The schema phase generally does what? Executes the DDL statements to create key spaces and tables. Prepares the workload schema file. Loads seed data into the data model. Schemes with my friend Tom. Right, executes the DDL statements to create the key spaces and tables. Okay, all right. And where are we gonna be here? Ooh, oh, look at that. Oh, Japrit pulls it out. This is like watching like the longest sprint where the three top people were going, and then all of a sudden, whoa! That's awesome. So yay, Japrit. If you were the top three, so Japrit, TDH, and Massey, please reach out to Jack Fryer so we can get you some swag. And congratulations on that. Appreciate you guys sticking around to take that. So with that, we are going to take just a quick break. Why don't we go ahead and get into the AMA at 2:20. And for the rest of you who are leaving, thank you again for attending. We really appreciate you coming and sticking with us. And for those of you who've been new to the stream, welcome, welcome. We hope that you come back and that you got something out of this. As always, you can always use the Discord chats to come talk to us. We're on LinkedIn. We're out in Twitter and everything. So, you know, by all means, feel free, come and contact us. And don't forget to get about community.datastacks.com, where you can definitely ask questions. We have a whole team of folks that are there to answer things. So again, we will just give about 5 minutes, and we'll come back and we'll do an AMA. Thank you. I should put on some music here. Hold on. Let me switch to some music.
I found someone new.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.
It would help if I turn my mic back on. Yeah, so everyone, try. I see your question. I know you can't attend the AMA. No worries. I'll get an answer from Shuki, and we'll give you a... I know the answer is yes, but I know you're looking for the other tools. Oh, there he is. He's back.
I'm here.
All right, let me get fixed here. I don't know where Eric went. He disappeared.
I don't know if Troy's still around. The short answer to that is that the command line options available in NoSQL Bench offer a few different ways of getting data out. I'll just list them briefly. You can send graphite anywhere. You can record CSV files anywhere in the file system. You can have it record HDR logs in HDR log format. You can have it record HDR stats. So those are just the selected statistics from HDR data. We're working on getting Prometheus native support working so that we have native labeling throughout the Docker stack, but that's going to take a little bit more work. For start and run, we're probably going to relabel that in terms of explaining it. We're going to stop using the term async with start.
Oh, are you?
Yes, the simple way to explain that is non-blocking execution of starting an activity in a scenario. The run is the blocking mode. Now, we haven't covered scenarios and activities and how they work together, but an activity is kind of the focal point of what we were looking at today, like the steps in a scenario. Those are each activities. And run basically tells the NoSQL Bench core to run that activity from start to completion before it continues on to the next step. And start allows you to run multiple activities concurrently because it doesn't block until the started activity finishes before it moves on to the next command. And that makes more sense if you look at how the name scenario has multiple steps listed. Well, what happens on any command line in NoSQL Bench is all of those commands that are concatenated together, as many as you want, are they're templated into a JavaScript scenario script. And each one of those commands directly maps to a JavaScript call. So it uses Graal.js, hooks into the Java runtime, so it's calling native Java code as well, so it's efficient where it needs to be, but it has a scripted runtime. So those commands are really just like template forms of an overall program. And so this is where for advanced testers, they'll find that secret access panel, they'll open it up, and they'll write scripts to do other things that maybe our command line macro versions of these things can't support. But that's for another day to go into the details on that. But the gist is that blocking and non-blocking activities are available, and start and run is how you do the non-blocking version and the blocking version of that.
All right, cool. Thank you, Shuki. All right, so I do see some others. Eric, do you see some questions you've been waiting for? I know there was a couple, and I told you to hold off.
There are a couple. Let me pull my notes back up here. Okay. So, what about using an existing data set as a benchmark data?
So there's a little bit of art in this. There's a little bit of science. The gist of it is that as long as you can hold the data in your local client memory reasonably, let's say you're not filling up all of your available heap space with the data so that the core doesn't have room to work. As long as you're not doing that, any amount of data that you want to load as what we might call cached seed data is great. The more the merrier. But you usually don't need as much of that as you might think to get realistic data shapes. And this really, the distinction, for when you need more or less, really, it depends on whether you're talking about dimensional data, like facets of values in a row where like the cardinality of that value may be a maximum of, say, 100, as in the parameters that we used earlier in David's examples. The contrast to that would be where you have a continuous value. Say it's a floating point value. That's the, you've got a medical record and you're recording the person's height, right? Yeah, it's only down to a 1/16 of an inch at the most finest, if you even do that, half an inch probably. But it will follow a distribution. The cardinality of values is going to be limited, but it does follow a distribution. It might just be easier to tell the system that, hey, I want a normal distribution, 5 foot 10 inches for typical American male or whatever it is, right? And have it quantize that to the nearest half inch. Well, that's a simple recipe. And that simple recipe takes the place of any moving data around. But where you need specific data to capture data from a system, what we generally do is we look at that data and we say, knowing the recipes that we have and the functions we have available, what's the best way to kind of emulate this data shape? And so there is a bit of acquired skill in doing that, because the function library is, there's some knowledge in knowing how to use it and how to compose these functions together to get realistic data generation. And that's why for most users we recommend initially that you just look at all the examples and cherry pick out the things that you like from there. This is also one of the biggest values in getting on the NoSQL Bench Slack, because you can say, hey, I need a recipe for this, and somebody will probably give you one. And by doing that, we broaden our library of examples that we're going to put into the simple builders that we're working on right now for workloads.
Awesome. So I'm seeing a number of questions kind of around one topic. So I'll try and kind of condense it down into one big ask. So performance testing around CRUD operations, not just inserts, but deletes and the tombstones and various things that a long-running system will encounter. Are there ways to use SQL Bench in more of that sort of a capacity?
There are, and this is where there's a little bit of esoteric knowledge, but I'm going to cover the concept of how you do that. So we talked about cycles being like the main seed for an operation. And if you think about the different CRUD operations that you would do against a database, and you can sketch the access patterns, like say how many deletes proportionally with what identifiers from some known set of identifiers. If you can identify that test scenario first and foremost, just in terms of requirements, then the rest of it is just knowing how to express that into functions, because everything else is just statements. So I mean, any statement that's a valid SQL statement, you can put in a workload. And you can run a scenario from a workload file with whatever parameters or customizations you need, but the key, where the rubber meets the road on that, is have the right bindings that will, upserts and deletes and, whatever the reads, the different CRUD operations in the right proportion with the right data, so that it has the result is meaningful for what mix you expect.
Right, maintaining something realistic, basically.
Basically, and there's one facility that we offer to make that easier, and that's that we can't cover everything in a session, but one of the things you can do is add a ratio on statements, and it just automatically makes that statement occur proportionally that amount of the overall statements. So for CRUD operations, you might say, hey, I've got 10 times as many reads as I have deletes. So set the ratio to 10, and you're basically there.
Got it. Okay, so another one here. Oh, this is a good one. Can NoSQL Bench be used for benchmarking SQL databases? Are there any barriers there?
It could, but currently it can't, but it will. And
is that just a plugin that's needed or something? Or?
It's just a driver. So, for example, in Java land, I mean, it's a Java-based system. NoSQL Bench is a Java product. All we need really is a JDBC adapter. Yeah. And the idea has come up with some of the contributors. Nobody's actually moved it higher to their priority list to get it done yet. So if somebody really has an itch to scratch there and wants to become a contributor to the NoSQL Bench ecosystem, that's a great contribution to have. We can say we want to do it, we'll get around to it, but we got a lot of things we want to do. Our focal point right now is making it easier to run and use with UIs, and we're working on UIs right now. So.
Fair enough. All right, so for those of you out there who are interested in that, PRs, we accept them.
Now
and by the way, sorry, go ahead, Dave.
Oh, no, go on.
I was going to say, we know that there's a lot in the code base. It's a big code base, because if we have contributors who want to get involved and don't know where to start, we'll actually start doing our own empowering, enabling sessions to acclimate people, show them where they really need to focus and how things will fit together. We'll do that. We'll train up and educate some contributors to see if they're comfortable getting their hands dirty in a NoSQL Bench project. I mean, that's just part of getting more contributors. And so if you feel that you want to get involved and you feel that you got some Java chops and you want to put them to use and be part of that, come to us, ask for help. We're going to help you do that.
All right, I've got one here that's more about the Astrakathon. I always say that wrong. It's
Astrakathon. Astrakathon.
Astrakathon. There we go. Yeah. It's from Frank. I have a simple application I want to submit. If I can't get the code to run completely, can I submit anyway? Yeah, you can submit it. You obviously document what's not there. And obviously, a fully working application will probably get more points than something that's not, just from the fact that it is, in fact, working. But we'd love to see the code. And who knows, maybe someone in the community, maybe one of the advocates or someone else could potentially provide the solution to whatever it was you're facing. So, yeah, absolutely. Go ahead and submit.
Yeah, so
I see a couple up there
go ahead.
that Eric posted as well. One from TDH. TDH is no longer here, I think.
I just lost sound.
I think we're still going. Yeah.
All right, cool. So what you can do in a binding is you can use hash. Hash pseudo-randomizes the value, apparently. It is deterministic, but the shape of it is pseudo-random. So that means that by setting the cycle range that you're using, you are actually predetermining the seeds that will be used for every operation in that activity. I want to use cycles 0 through 100, and then you, in a different iteration, say I want to use cycles 100 through 200. The template of everything is exactly the same, except seed for every operation is now different. And if it uses the built-in hashing that a lot of the convenience functions already do for you, it's just going to be a different set of data, different set of operations in terms of the data in the operations, but the operational template and access patterns will still follow the same patterns. I mean, it'll still follow the same patterns. So the cycle for a given, the cycle number for a given operation is the seed. Another one of the questions is it possible to use batches or inserts with NoSQL Bench? Yes, in the current form, it's easy to do it with inline batches, meaning that can fit within a statement. So you have begin batch and all that. We don't have a convenient template right now for stitching together a batch over multiple statements like you would do independently. That gets a little complicated in terms of making it easy to use. So for now, we've opted to stick with inline batches. To do that, you do have to actually use the bindings distinctly within each row in the batch. So it's a little bit extra editing to add, bindings with suffixes, numbers on the ends for each one of those places, and swizzle the data if you want. So there's a little bit more typing involved, but it does work.
Awesome. Let's see here. Got some more on tombstones.
Yeah,
I think
I've seen that. Did we? Because honestly, I was so busy killing all the stuff on my machine because something was degrading. I didn't see. I know that VJ has asked about the tombstone one. Did you guys talk about that?
Yeah, that was covered. A couple minutes ago. Okay. I think the basic idea, and to kind of put it in the simplest terms possible, is create the workload that creates the behavior, and then set up the corresponding workload for deletes, updates, whatever, and essentially you can get that going. Let's see.
I do see another one. Abalash, in Discord was asking, in a distributed environment, can we use the tool to emulate a scenario to have high load on 2 nodes of the 6 nodes? That's kind of interesting.
It is an interesting question. The answer is yes. I think the question is, how do you do that? But the more important question is, why do you want to do that?
Yeah,
right.
yeah, that was my first thought as well, right? Like, unless you're...
if you're trying to reproduce something that you've seen already somewhere, I think the better investment of effort would be to figure out why and avoid doing that, right?
I almost wonder if there's potentially a partition issue or a large partition issue in this
Top
particular questions past. Where they're seeing something with.
Let me take a stab at a recipe for that real quick. Let's say that you have a fairly coarse cardinality in your partition identifiers, right? And let's say if you just, for example, RF1, you have 100 partition identifiers, and you set the distribution up so you use like a Pareto distribution, so that one of the identifiers comes up very frequently. That's going to cause one or two nodes to be loaded with a lot more data. If you do a billion inserts and 100 million of them go to the same partition, and the other 900 million are spread across 99 of the partitions, you're going to see a set in some large partitions. You have to add an additional identifier for the row in there as well, the logical row. But you can do that. I mean, you can simulate that kind of activity without knowing why you would be wanting to do that and what the signature of the actual lack of load distribution is. It's hard to say that you would actually be simulating the same cause. So it just raises some questions, like what's the real motive for wanting to do that? Because normally you wouldn't want to run a production cluster like that. You would want to make sure that you have good distribution, that kind of thing.
Yeah. I got another one here. How anti is allow filtering with small partitions?
It's always anti.
It's always. And in fact, if you think about what you're doing with small partitions, is you're essentially guaranteeing that whatever you do will have to hit everything no matter what. So even if you were trying to somehow, I think what you're trying to do here is limit allow filtering to a small kind of slice of the pie manually. Smallest partitions would actually make that worse.
Yeah, so. And something to point out, TDH, I mean, it's a great question, really. And it may have been subtle, but when I gave the examples earlier of the Astra database and the 6-node cluster that I had, I purposely pointed out the size, the total size.
Yeah, tiny data set.
It wasn't even a gigabyte, right? Spread across 6 nodes, 6 properly sized nodes, okay? That was enough to cause 6-second read latency. Just
Which
to put
in
that
the
in perspective.
World, 6 seconds is, it might as well be a year.
Yeah, it's ancient, right? That's orders of magnitude more than what it should be.
And there's another pattern that we've seen a lot in this exceptional type of like breaking the rules because we think it's okay. Everything like this where you can specify something that is an anti-pattern, it is there for a reason. But usually the original reason is no longer valid.
Yeah.
So in this case, you can say, well, we know the cardinality of the allow filtering is going to remain low. We hear that a lot, and it's almost always incorrect because a successful service, successful deployment grows, and therefore it's death by 1,000 cuts at some point, and it's death by 1,000,000 cuts. I mean, you have to absolutely know that the data shape is not going to change, and nobody really does in practice.
And I just noticed too that we kind of misunderstood. We slightly misunderstood TDH's question. He asked within, not across partitions. How
within
is
small partitions?
It's still enabling scanning over data.
It's still bad. You should not use it. Flat out.
It's an unindexed scan. No matter what, right?
And to kind of just add a little color to this, real world situations, the amount of scenarios I've been in where someone in production is saying, "Hey, my performance isn't where it should be." This is always on like one of the first 2 things I check when I ask.
Totally.
Well, can I see your queries? And 9 times out of 10, probably actually 10 times out of 10, in all honesty, allow filtering is in a query. And when we change it to be what it should be, most of the time the problem goes away. It's not every time, but most of the time that problem goes away. Yeah. So allow filtering, avoid it, I would say at all costs. It's a data modeling issue if you're having to turn allow filtering on.
It's the difference in the cost of scale, right? If you're using it where it increases the overhead on the server side by a factor of 10, are you going to buy 10 times as many nodes? That's real money, right?
Yeah.
I mean, that's a real operational problem to manage.
Plus all the network additional network resources you would need to now support that full network size cluster.
To not use allow filtering sometimes requires a little bit more data in terms of having an inverted index on another table.
Yeah.
But the design cost of doing it is much lower. Plus, it scales in a manageable way after that, and that's all we're about here: scale.
That's right. Scaling with performance. Yeah, performance at scale. Yeah.
Yeah, absolutely.
So Avalanche had a follow-up there when we were talking about the allow filtering piece in the beginning, and said bad partitioning is the real cause of somebody's bad design. Now, I agree with that to a point. However, you could have a solidly designed data model, and this may not be what you meant, Avalanche. Always correct us if you need to, but you could have a solid data model. But if you use funny enough, that's exactly what I did in that experiment that I was showing you earlier, where that data model, for all intents and purposes, if used correctly with the right partitioning in your query, will perform at scale with no problem. But just doing that one thing with using allow filtering and then going outside of my partition keys was enough to significantly increase the load on my system. Right. So it is
lumpy data is often a culprit for that. Yeah.
And the easiest solution there to make the query you wanted to run work would have been, okay, let's create a new table. One new table, and we wouldn't have had that problem. We could have kept our latencies down, kept everything looking good. But okay, what do we got here? We got a couple questions on tombstones. What are tombstones? Not going to get super deep into that. There's a lot of blogs, documentation, and various things out there on it, but just the short 20-second version. Cassandra doesn't actually delete when you do a delete command. It marks something for deletion later, and it makes sure that that marker is distributed around the cluster. And in order to guarantee that, it needs to live for a certain amount of time so that we can basically guarantee that the marker has marked every single piece of that data within that cluster. So a tombstone is just a, hey, delete this later sort of marker that lives within your database.
Zombies.
Right, it prevents zombies data from coming back if somehow something got missed somewhere. Again, that subject in and of itself is a great discussion that we could probably talk for a couple hours on, but the 20-second version there in a nutshell. Okay, what else?
Yeah, I'm good scanning through stuff to make sure we didn't miss anything.
Yeah.
Oh, I don't know if we answered this one for Rashmi. Do the tools allow you to give distribution for CRUD operations?
To give distribution, yes. So the detail on that is we actually have bundled in and customized slightly the next version of the Apache Commons Math Statistics distributions library because we have to use it in a very special way to get O1 relatively stateless, what we call variant sampling. So variant sampling. So what we're doing is we're allowing you to use any of the distributions that are part of the Apache Commons Math Statistics library. That includes all the discrete distributions. That includes all the continuous distributions. And we have a YAML in the example somewhere that give you an in-YAML example of actually calling with typical parameters. But what that means is if you have the right function, you plug in the right parameters for that distribution, you're going to get that shape. You can get Pareto, you can get normal, you can get binomial if we're doing discrete or whatever. And in some cases, we'll even automatically convert a discrete to continuous or vice versa, so that it's just easier to pick out a function that works for what you're doing. And so if you're talking about degree distribution, like branching factor, things like that, it's exactly that effect when you use it in an identifier, like in an identifying field position, especially when you're talking about some kind of external reference to another table. It's exactly the same thing as degree distribution in like the graph sense or the foreign key sense.
All right, another question here.
Yeah, I think
Are we
it'd be
planning?
last one? Oh, go ahead.
Oh, I think I got a couple I can hit really,
Okay,
really
yeah,
quick.
yeah. We'll do a couple more.
Are we planning any session for monitoring and tuning Cassandra? If there is enough interest, put it in the feedback. If we're seeing it pop up a lot, we can definitely look into doing something with that. And then we've got one, is there a way to detect from the server-side applications using allow filtering? So I'm assuming some form of like a warning, we're seeing queries with allow filtering on. Maybe this is something I should ask David and Shuki, but I know back when Ops Center was being used, it actually had a rule that would trigger. Are there other common things you guys have seen out there?
I think it's a challenging thing to do because you have to sample or explicitly check the syntax. But as we see in the chat, guardrails is a concept that we're coming up with to make it so that things like this are programmatically verboten according to the administrator's configuration, and will not allow it to happen, basically. So at some point, it will be a configuration option to disallow it. It's not there yet, but you can keep your eyes up for it.
Yeah, that's right.
Yeah. Awesome. Okay, well, I think that's about time for us, so we should probably let everyone here go. Thank you all for showing up. This has been a really good session. This is something that a lot of people don't think about when they're actually building an application, but if you want your application to be up and stay up, this is really some steps that can't be skipped here. So, thank you all for coming. David, any last
everyone?
words?
No. Again, just to kind of echo what Eric said, thank you all for staying on, doing the AMA. We really enjoy these. We find that there's some really insightful questions and such that are asked. And again, for those of you who've been staying with us for this whole time, 7 weeks you've been with us. This is wonderful. We'll see you again next week, and then we're going to have our little special session there at the end. Keep at it. Do the homework. I swear there is some really good stuff in there. And again, don't forget about the overarching DataStax KataCoda scenarios. There's some really awesome material that has recently showed up in there, and there is more coming. So definitely something to keep a look at. And again, everyone, thank you. Go take a break. Go have some coffee or go to sleep or wherever. Thank you guys so much. Take care.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact, empowering them to achieve wondrous feats.